Apa-apa. Kalau ada ya enggak masalah.
Apa salah ya?
Masalahnya kan dia di putih, bukan kepala. Kasih saja pertanyaan.
Iya, tidak apa-apa. Tapi berarti oke. Berarti di atas nanti
Oke.
Pak Karo, nanti Pak Perat yang Pak siapa Ricardo yang pandu ya.
Iya, iya.
Oke.
Pak Hendri, untuk tulisan expert speech dan keynote speech-nya tetap ya, Pak?
Berarti ada perubahan dong, Pak.
Tidak usah ubah, tidak usah ubah.
Tidak usah ubah, oke.
Iya. Oke, YouTube sudah oke ya? Mas Ivan, YouTube sudah oke ya?
Sudah, Pak, ini sudah di YouTube. Coba
Oke,
saya
oke.
cek, Pak, YouTube-nya Unipa apa, Pak? Saya cek.
Di sini sudah ada Mas Andra kah?
Iya, halo Pak. Selamat
Ya.
pagi semua. Nanti saya bagikan di WhatsApp Pak ya. Tunggu saya lagi sementara copy linknya.
Sip, sip. Iya, makasih.
Sudah, Pak Hendri, sudah ada di YouTube.
Oke, oke. Makasih. Waduh, ini saya kena AC langsung lagi nih. Bisa di ini enggak ya? Mana tadi remote?
Ini virtual background-nya yang
Bu Rina tes sound.
Mohon maaf, Pak Hendri, hostnya masih Pak Hendri.
yang punya terbalik apa ya? Mic, test sound.
Oke, oke. Sebentar saya kasih. Mas Andra. Mas Andra.
Iya, baik Pak.
Bisa kasih hostnya ke itu, Ivan itu.
Baik, siap Pak.
Nanti dia ngatur.
Kemudian pakai speaker sudah orang satu suara di sini. Oh, ada orang yang ada di sini yang cari yang mana?
Pinter ya? Nilainya tinggi ya? Hah? Jangan repot si Dondi deh. Sama dikit.
Iya, Bu.
Halo Pak RT.
Halo,
Assalamualaikum Pak RT.
selamat pagi.
Pagi semuanya, all participant, all audience. Nice to meet you.
Pagi, morning.
Good morning, Pak Eti. Stay
Ya.
safe, stay healthy.
Oh, thank you.
Halo Pak Jul. Kalau dia mengambil, kita ada ganti lagi.
굉장히 예쁜 거예요. 그래서 내가 그 관사님한테 그렇게 여쭤봤는데 그게 가능할까? 그렇지. 그냥 좀 움직여야 될 수밖에 없는 일이 생겨갖고 일찍 일어나게 되면서 어렵겠죠. 그러면 아무래도 이게 그냥 뭐 주문이나 그게 한 평가라서 어떡하지? 내가 그러면은
Selamat pagi bos.
하고 소리를 한 번만 해보고
Rajin sekali datang pagi. Saya kasih kuliah di PT dulu yang tanah toh. Baru kalau mereka ada banyak baru kita mulai, kalau memang sedikit. Sini saja. Kita terbuka toh. Mau praktek jadi. Yang hama sudah selesai.
Good morning, everyone. I hope you are doing well. Before we start today's conference, I'd like to kindly ask you to mute your microphone. Please be sure that your microphone is off during the opening of ceremony in order to avoid interruption. Thank you for your kind cooperation and attention. Good morning, ladies and gentlemen. We are delighted to welcome you to the University Forum for Disaster Risk Reduction Conference with theme Disaster Risk Management for Climate-Related Hazard in Tropical Countries, Progress and Challenges, September 29, 2021. It is the privilege to welcome His Excellency Rector of University of Papua, the Honorable Head of Badan Penanggulangan Bencana Nasional, Head of Badan Meteorologi, Klimatologi, dan Geofisika, Head of University Forum for Disaster Risk Reduction, Chairman of the conference. I would also like to welcome our Excellency expert speakers from some international university that are from University of Hawaii, from Hiroshima University, from Changbak National University, and from University of the Philippines, Los Banos. Also present with us, the honorable invited speakers from Badan Meteorologi, Klimatologi, dan Geofisika, from Kementerian Koordinator Bidang Kemaritiman dan Investasi, and from Muhammadiyah Disaster Management Center. Also, for all the invited moderators, presenter, and participants of the University Forum for Disaster Risk Reduction Conference 2021. Thank you for joining this conference virtually. We hope that all of you will benefit and gain knowledge through this conference. So just to give you a heads up, the reason for holding our today's conference is by paying attention to hydrometeorological disasters in several countries, including Indonesia, where in 2021, 95% of the total disasters are derived from hydrometeorology, and also archipelagic countries and small islands, which are more vulnerable to climate change and disaster. Responding to that, the University of Papua, in collaboration with the National University Forum for Disaster Risk Reduction, held this conference, which is focusing on managing disaster risk due to climate-related hazard in tropical countries. It is expected that through this meeting, national and international experts and practitioners will share their knowledge, experience, thoughts, and opinions on how to mitigate, adapt, prepare, and build resilience to climate related to hazard in line with sustainable development. Ladies and gentlemen, before we continue our agenda, for a brief moment, we would like to invite you to kindly be seated and listen to Indonesian national anthem, Indonesia Raya. Distinguished guests, ladies and gentlemen, we will start today's event by opening remarks delivered by the chairman of the University Forum for Disaster Risk Reduction Conference. Please welcome Dr. Henry. Dr. Henry, time is yours.
Okay, thank you, Serina. Shalom. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning to all participants in Asia, and good afternoon to my colleagues. First of all, we pray and thanks to the God that we can breathe health and then can meet together in this Zoom. On behalf of University Forum for Disaster Risk Reduction International Conference with the topic Disaster Risk Management for Climate-Related Hazard in Tropical Country, Progress and Challenge, I would like to welcome you all for this conference. Before that, I would like to extend my great gratitude to the keynote speaker, the Excellency Bapak Dr. Raditya Jati, as Deputy System and Strategy BNPB from the National Agency for Disaster Management. And then the second, the Excellency Bapak Dr. Ardasena Sopaheluwakan, Head of the Center for Applied Climate Information Services, as a representative from the National Board Meteorology, Climatology and Geophysics. My appreciation also goes to the Excellency Bapak Rektor Universitas Papua, Dr. Meki Sabrin, together our Bapak Director of a Graduate Program and member, plus our colleagues from the University Papua. And together with the Eastern University, Universitas Patimura, Universitas Khairun, and Universitas Cendrawasih, for thanks for the help and cooperation. I'm also express my appreciation also to the expert speaker, especially from my colleagues from the University of Hawaii, Professor Kalkin. So this Professor Kalkin has a long history collaboration with the University Forum for Disaster Risk Reduction, especially in the eastern part of Indonesia, to enhance our research, education, and capacity building. The second is Associate Professor Dr. Lee Han-shu from Hiroshima University. So Dr. Lee is also my senior, and thanks for sharing the knowledge for modeling, simulation for climate-related hazards. And then the third, Professor Dr. Sung-soo Lee from the Chungbuk National University, Korea. And then also the last one is Professor Joan M. Pulhin, PhD from the University of Los Banos, Philippines. So my express appreciation also to the invited speaker is from the first is Dr. Nelly Riyama as the head of the research center for the National Board Meteorology, Climatology and Geophysics, and also for the Dr. Andreas P.P. Patria from the Coordinating Ministry of Maritime and Investment. And the last one is Dr. Ramawati Hussein from the Muhammadiyah Disaster Management Center. My appreciation also bring for all participants that in the parallel session that's come from Japan, India, Bangladesh, and Indonesia, starting from the Aceh until to the Papua. So, plus distinguished guests is from APIC, WRI Indonesia, Mercy Corp, and the other our friends to support our international conference. So hopefully our conference will be bring important value for sharing knowledge and lesson learned how to adapt the climate change and also the climate related hazards, especially in the eastern part of Indonesia, which contain 4,110 small islands in West Papua, together with the Maluku 1,422 and the North Maluku is 1,474 small islands. And then the all paper from this conference will be published in the IOP conference series. And the last session, our team will be make a conclusion and bring the brief policy to our government to prepare the disaster risk reduction related for the climate disaster. So please enjoy the conference and nice to meet you all. Thank you.
All right, thank you, Mr. Henry, for your opening remarks. We would also like to listen to the welcome speech delivered by the head of University Forum for Disaster Risk Reduction. Please welcome Dr. Eko Teguh Paripurno. Mr. Eko, platform is yours.
Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable keynote address, Dr. Radia Jati from National Disaster Management Agency, also Dr. Ardia Sena from Meteorology, Climatology, and Physical Agency. Honorable invite speakers from Hawaii University, Chumbuk National University, University of the Philippines, Los Banos, and also Hiroshima University. Honorable invite speaker also from Meteorology, Climatology, Geophysical Agency, Ministerial Coordinating of Maritime and Investment, Bandung Institute Technology, and also Muhammadiyah Disaster Management Center. Ladies and gentlemen, at this moment, let us express our gratitude to the merciful God who has granted us with blessing and grace that we could meet online here to attend this conference. Let me extend my warmest greeting and welcome to our honorable speakers and participants, particularly those from abroad. Ladies and gentlemen, we must still be prepared for climate change-related disaster. Referring to the Paris Agreement, the average world temperature will rise 3.2 degrees Celsius in the last decade. Therefore, this seminar is one of our efforts in strengthening and reducing the risk of disaster due to climate change. That is an occasion for positive contribution, ideas, and knowledge sharing regarding the disaster risk management for climate-related hazard in tropical countries, especially in Indonesia, more especially in Eastern Indonesia. University's Forum for Disaster Reduction has the vision to make Indonesia a leading country in the development and application of science and technology in disaster risk reduction. We have 70 members from the study program and research center of universities in 15 provinces in Indonesia. That we invite you to join the University Forum Disaster for Risk Reduction together to reduce disaster risk and promote disaster education for the community. Many thanks to the seminar committee from the University of Papua who have successfully held this seminar. Finally, I hope all participants of the conference can find important areas of common ground of the best way for achieving the broad goal. In the last, I have great pleasure in formally declaring this convention open. Bismillahirrahmanirrahim. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Mr. Eko Teguh Paripurno, for the welcoming speech. Distinguished guests, ladies and gentlemen, the University Forum for Disaster Risk Reduction Conference is officially open. And before we close the opening ceremony and continue to the main agenda, for a moment, we will have a short photo session. Please kindly all the panelists and participants to turn on your camera for the photo session. Okay, we have like 3 slides. Okay, are we all ready? You can smile to the camera. I will count to 3, and everyone can smile to the camera. 1, 2, 3. Slide 1 and slide 2. 1, 2, 3. Slide 3. 1, 2, 3. One more. We're going to raise our hand as a symbol of our spirit of the conference. So everyone, please raise your hand and make the fist in the air. Okay, I will count to 3. 1, 2, 3. All right. Thank you very much, everyone. Ladies and gentlemen, we will continue the event with keynote presentation. In this session, we'll have Dr. Raditya Jati, SSE, MSE, as Deputy of System and Strategy, Badan Nasional Penanggulangan Bencana, and also Dr. Ardasena Sopaheluwakan, Head of the Center for Applied Climate Information Services, Badan Meteorologi, Klimatologi, dan Geofisika. The keynote speech will be moderated by Professor Dr. Ricardo Tapilato. Please welcome our moderator, Professor Dr. Ricardo Tapilato. To Professor Ricardo, time is yours.
Have your attention, please. I have to adjust the schedule in the last minutes because there has been a change. So we are going to have a keynote speaker from 2 speakers. The first one is Dr. Ardasena Sopaheluwakan, and the second one is from Professor Carl Kim. The presentation as the moderator for this session. First of all, I would like to welcome all of you to this session of keynote speeches. In these occasions, we would like to have 2 presentations. The first one from Dr. Ardasena. Please allow me to sound friendly call you Dr. Arda.
Good morning, Professor Tapilato. Selamat pagi, Pak.
Koneksi Pak Ricardo kurang bagus ya, Pak.
Selamat pagi, Pak Arda.
Selamat pagi,
Pak
Pak.
Sena. Namanya. Jadi ikut-ikutan. Monggo.
Saya langsung saja, Pak Eko.
Iya, monggo.
Oke, baik. Mohon izin. Allow me to share my screen. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning to everyone. I hope everyone is in good health and good spirit during this pandemic time. First of all, I would like to convey my sincere gratitude to the kind invitation of this University Forum for DRR of kindly inviting BMKG to this very important and relevant fora. I am representing our head of the agency, Professor Dwi Koreta Karnawati, who unfortunately was not able to attend this very important meeting because he have an important engagement with the Ministry of the coordinating Ministry for Maritime Affairs. But that doesn't mean that she thinks that this forum is not important. On the other hand, I think she still supports very much this very important conference, as well as the university network or university fora. And I would like to represent her, that she is very much in support of this kind of forum and activity, so that the academia and the operational side, which is in BMKG, can collaborate hand in hand to make activities in adaptation or mitigation to climate change. So my name is Ardesena Sopehloakan. I'm currently in charge of the Center for Applied Climate Services in BMKG. I will be speaking as requested by the organizing committee, or Pak Eko, in the sense of the role of BMKG to face challenges in climate-related disaster. So basically, there is three kind of messages that I would like to convey. Is the first message is sort of laying out the background of the current state of the current state of climate change, which we actually are familiar with, but nevertheless, kindly allow me to just present some key figures related with the global climate change, as well as the climate change which happens in Indonesia. And I will continue with its impact in disaster. I think everyone in this forum is also quite familiar. And the last item which I would like to put in the table in this forum actually is an invitation for everyone in this university forum to join hand in hand to make the so-called climate services. It's a kind of a framework for adaptation to climate change. So if we look at the global scene or the global report related to climate change, there is three quite prominent reports that is regularly published related to climate change. On the right-hand side, you are of course familiar with the IPCC reports. They just made a big splash with the assessment, with the sixth assessment report a few weeks back. That is more or less conveying the message of our future climate. And the second report on the left is an annual report provided by the World Meteorological Organization on the state of the global climate. It informs the society in the world of how the climate is changing from year to year. And I'm also involved in reporting to this, in making this report. And the third report is how the economic community perceive risk, especially climate change risk, to the global economy. So let me perhaps start with the last one. So the global risk report, the recent one, 2021 by the World Economic Forum. From year to year, they identify extreme weather as sort of the one of the prominent risks, even before COVID came. In terms of the impact, so illustrated here virtually, and as well as its likelihood of occurrence, and also climate action failure. So the economic the people who are active in economy already know that the failure in acting to climate change or failure in responding to climate change would, in the long term, provide quite a costly economic impact. Going to the report from IPCC, last year they published a special report on 1.5 degree. They argue that although countries have committed themselves to put to hold global warming under 1.5, but with the current rate of global warming, they see that the 1.5 degree threshold will inevitably be reached between 2032 and 2050. So that is actually quite soon, and that is perhaps within our lifetime. Not even the following generation lifetime. So they also argue that if we stop emitting now, then the chances of not exceeding 1.5 degree is actually quite small. So the message I think here for everybody to take, including us, is how we can best adapt to this situation. And of course, still continue to mitigate with climate change. Now, allow me to continue with the state of the global climate. There is usually several climate indicator or climate headline, we usually call them, which is used to monitor the state or the change of the global climate. Atmospheric composition is the first one. Temperature and energy is the second one. Rainfall is, of course, quite an important one, considering its impact to livelihood. Ocean is the fourth one, and the cryosphere or ice cover is the last one. So the global climate statement provided by the World Meteorological Organization, which is published early on March this year, informed us that 2020 is one of the 3 warmest years on record. It is actually the second warmest year after the 2016 year, after the strong El Nino event that happens in 2015-2016. And 2015 to 2020 were the 6th warmest year on record. So the warming is continuous, and 2020 is already a 1.2 degree above the pre-industrial baseline, which is just 0.3 short of the global target. And due to the warming, the majority of the heat is being stored by the ocean. So although the terrestrial area have a sort of fluctuation in average global temperature, but if you look at the figure below, that the ocean heat content keeps on continuing, it's informed us actually that the future signal of climate variability and climate change is actually in the ocean. And so it is actually one important aspect that we should not neglect. Indonesia is surrounded by ocean, and I think that is something that we have to consider quite seriously. Sea level rise is, of course, also a major threat. The rise of the sea level is not uniform. We can see that the rise of the ocean near the waters of Indonesia is higher compared to other areas. That is, of course, also influenced by how the ocean is circulating, and it will, of course, impact on the small islands that we have in our waters. So perhaps in the future we will not have 17,000 islands anymore. It may reduce. And BMKG also monitor the atmospheric composition through a special global atmospheric watch station in Bukit Kototabang in West Sumatra. Shown here is the measurement taken at that location, shown by the blue curve, while the black curve is the global average, and we can see that actually the background atmospheric composition of CO2 in Indonesia is generally still less than the global average, but it increases with the same trend of around 2 ppm a year. And I think this is the concern that we have to take on board on how we can reduce carbon emission to the atmosphere. We are not only measuring CO2 in the GO station, we also measure methane, N2O, and SF6. N2O, CO2, and methane are also occurring in the atmosphere naturally, but SF6 is purely anthropogenic, so it's purely made because of human activities, and we can see in the graph here below that the trend is continuously increasing. Related with, there is a relation actually between air quality or pollution with economy. I plotted here the regional GDP or gross domestic product of the 10 biggest city in Indonesia. Vertically and horizontally is the one of the metric of pollution, or in this case is total suspended particulate matter. As you can see that there is a sort of collinearity between the size of the economy and also the pollution level, which actually indicate that our economy is still driven by carbon economy. And if we segregate the size of the city, megapolitan, metropolitan, and medium to big city, you see even clearly that the size of the economy corresponds very much with the level of pollution. That also correlates with acidification or hujan asam or acid rain. The more pollutant the atmosphere, it correlates with the level of acidity of rainfall in big cities. Jakarta and Semarang as the most acidic city that we recorded through testing of rainwater. Now going to the headline indicators of climate change in Indonesia, the global or the average increase of temperature is in Indonesia is actually slightly less than global, but that doesn't mean that we should not be worried. But on the other hand, it goes with the same trend, that the trend of the average temperature is in Indonesia is significantly also increasing after the 1970s. We also recorded that 2020 is the second year, the second hottest year on record after 2016. So it's the same as the global average. How about extreme rainfall? Yeah, everybody kind of knew that the trend of extreme rainfall is also increasing in Indonesia. We measured that from way back several decades ago, that we can actually see there is a upward trend of number of days of having quite extreme rainfall, in this case as a measure of 150 millimeters a day. Daily maximum rainfall in several of the big cities in Indonesia is also actually quite spectacular. Quite a number of cities have maximum rainfall recorded of more than 200 millimeters a day. So that is something that we have to take care of or take into account when we plan to adapt for climate change. On the cryosphere side, we are quite fortunate actually with 2 or 3 other countries of having a glacier in the tropics. This is actually a special case. In Indonesia, we call it as salju abadi or everlasting snow, but it's actually an ice cap on top of the Puncak Jaya. It reduces from year to year. Annually, it decreases around about 1 meter, and presently it's only I forgot precisely, but I think it's around 5 to 7 meters. But the highest decrease occurred in 2015 and 2016 after the strong El Nino event in Papua that affects very much the ice cap in Papua. So with the current rate of melting, we can foresee that actually the ice cap in Papua will eventually vanish because the surface temperature in the Puncak Jaya is already above 0. So I think with that condition, the ice cannot sustain. That change in climate in affecting the variability as well as the extreme event occurrence resulted in a considerable number of disasters in Indonesia. The majority annually, more than 90% are related with weather and climate or hydrometeorology, and this is quite a number, quite a lot of number of disasters that I think we should build resilience to cope with the impact. I personally also noted that there is an interesting asymmetry between hydrometeorological related disaster with geophysical related disaster or earthquake and tsunami. That the number of deaths in earthquake and tsunami are usually considerably larger compared to climate related disaster. So I picked just for example 3 major earthquake events: Lombok, Sulawesi, and Sunda Strait, which happens in 2018. Compared to the 2015 El Nino as a representative for the climate disaster part. So the number of deaths and casualties for earthquake and tsunami or geophysic type of disaster are generally larger than climate-related disaster. But in the contrary, its loss and damage in terms of economic size is the opposite. Climate-related disaster cost much more in economic scale. For instance, here shown for the 3 earthquake disasters compared to the 2015 El Nino event is actually tenfold or 1 order of magnitude larger than the geophysical disaster. So I think that is also an interesting aspect that we have to take into account in designing adaptation measures to climate change. So yeah, we know that there is a strong need for adaptation in response to climate change. For an event which happens in the present weather, we can only respond to it, but there is an opportunity actually to build preparedness and planning in light of the seasonal scale or the climate variability side of climate change, of climate, but also we have the opportunity to have a better planning and responding to climate change. And that is our proposition, that actually climate services here can play a role, and that research is a key element. And so there is a plenty of space or plenty of room where the academic community can support with the research and activity in building climate services for many kinds of sectors. And we are very much welcome in collaborating with that. Let me show, for instance, a couple of examples that we also built ourselves in BMKG, but also some examples that we built with our partners in university for several key sectors that are impacted by climate or climate change. For instance, disaster, insurance, tourism, air quality, renewable energy, agriculture, health, infrastructure, water resource, and forestry. I will not show them all, but I will just highlight a few examples. The first one is our interface mechanism to translate climate information for farmers. We call this mechanism as Climate Field School. It is actually a mechanism to translate the climate information for farmers in an easy and understandable way. It facilitates adaptation for local climate risk through suitable strategy and crop planting according to the local climate. It also tries to actually stimulate sustainable agribusiness where climate information from BMKG actually play a crucial role in planning. So we are just one of the actors in collaboration with the regional with the agriculture extension worker, or in Indonesian we call it as penyuluh, and also with the farmers and with the local agriculture department. Through the years that we have executed this activity, we recorded a significant or a proven increase of crop yield after the climate field school were implemented. The size of the circles here show the increase of the harvest size compared to the baseline in that location from year to year. Even at the midst of El Nino in 2015, we are able to support the adaptation of farmers that resulted in 39% increase of the yield in the particular area that we had that experiment a few years ago. The following example is, for instance, climate information with for health sector. We have a close collaboration with a biomathematical group in ITB. We designed a model first for dengue and climate relation, for which eventually we tailor that to an operational product which is updated every month for the province of Jakarta and Bali for the time being. So if you are resided in Jakarta or in Bali, we have a special product that is actually estimating the level of dengue risk from month to month, and that is actually quite accurate. We have an accuracy of around 82% over 3 months, which is actually sufficient or more than enough time for the local health department to take appropriate action. The following example is climate services or climate information for forestry. We are able to tailor climate prediction, a seasonal forecast into the risk of forest fire. This product is now already operation. This was designed by our own research in-house through the Center of Research and Development, and it is quite accurate in linking the coming climate signal in the following months with the risk of forest fire, where we verified the accuracy is around 0.87, which is actually quite good. Another climate services example is our support for renewable energy. We have a static map of solar power potential or potensi energi surya in Indonesia throughout the country. I think this is suitable for planning, but also for developing purpose of for solar plants. not only this static map, we have also an operational prediction of solar energy potential, 7-month lead time, which is now operation. It predicts the level of solar radiation to for 7 months lead time. If you are interested, you can go through our website as shown here. An interesting case, perhaps related with disaster also, that we have this experiment is so-called the catalog of extreme event. It is run actually as a regional experiment in Southeast Asia and Australia, where we catalog extreme events in the weather and climate side. And our argument is that if this is linked with the loss and damage database that we have in BNPB, which is now I think a work in progress, a discussion between BMKG and BNPB, is that it will assist us in the assessment of climate change impact to disaster. So if we see an annual increase of from year to year of the number of hydromet related disaster, the question is that the number of disaster related to climate, is it because the frequency of the extreme event that is increasing, or on the other hand, whether there is also a contribution from the vulnerability side? I think with such experiment, this question could be answered. And it's also a facility to assist in building impact-based early warning information. When we link the weather and climate forecast with impact information, I think it is more suitable for sectors to adapt, and it's also perhaps could facilitate the analysis for risk transfer through insurance. So the result of the system, for instance, we can see which part of the area is regularly hampered by drought, for instance, by extreme rainfall, by forest fire, and by landslide. And this is sort of a basis to make a vulnerability map. The last example which I would like to show is our close collaboration with the water resources sector. We are providing our seasonal forecast of rainfall, which they feed into their system of water resources. So we have an integrated system that manage the water resources in Citarum River Basin operationally, so they can manage quite well the reservoir in responding to the upcoming season. So let me perhaps conclude this presentation by not providing a conclusion, but actually allow me to instead put a challenge on the table to this forum. We know that climate change is actually inevitable, that mitigation and climate change and mitigation and adaptation is actually a necessity. So the challenge which we, BMKG, would like to put in the table is the following two questions actually. Can actually the collaboration with academia show the long-term impact of adaptation, or whether we can show or not that the cost of adaptation investment is more efficient over time than responding to the actual or extreme event that is presented just in the near future. The second one is can the academic community play a role in translating the basic climate information, which is quite abundant in BMKG. We have plenty of data and products to actually an actionable information and actionable and suitable planning for sustainable development, for instance. Can we tailor this together? And I think we are very much welcome for collaboration with everybody. We can contact BMKG, or you can distinguished delegates are very much welcome to contact me personally also, whether we can collaborate to have some activity with real output, so that we can help and assist our country better in adapting to climate change. So that is perhaps the contribution from BMKG. We are welcome for future interaction or future collaboration very much. With that, I think I would like to hand over back to the moderator. Thank you very much for your kind attention. Wabillahi taufiq walhidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Arda, for the excellent talk. Now we're moving to our session. Please welcome Professor Kim. Professor Kim is a university professor at University of Hawaii at Manoa, who will be speaking to us on climate, cause, and crisis, planning for resilience. Without further ado, I would like to welcome Professor Kim to deliver the presentations. The time for 15 minutes and the floor is yours now.
Thank you so much. It's great to see so many good friends and colleagues. I wish I was with you all in person. And I hope to see you all soon, either in Manokwari, which I think I was last there in 2017, or in Hawaii. Actually, this picture behind me is taken from my house, overlooking the Diamond Head volcano and Waikiki. I'm an urban planning professor, and so I think my talk really follows the previous talk that Pak Ardhas Sena gave us. And I'm accepting his challenge. I thought it was a really excellent presentation. And so if I can, I would like to share my screen and then start my talk, which I think you will see that there is some relationship. Okay, I titled my talk for today, Climate, Coast, Cities, and Crises. And what I'm going to talk about is climate change and really talk about some strategies for adaptation and mitigation and risk reduction, some tools, some methods, some recent work that we are doing in the United States. And I think it is related to these different crises that we're having right now. By way of background, my research has been in terms of studying accidents and transportation. And in Hawaii, they've given me a nickname, Dr. Disaster, because I've studied low probability, high consequence events, starting with automobile accidents. In which there are interactions between human, vehicle, roadway, environmental factors. And it brings together science and engineering and social science. And I want to make a case today that the way that we think about preparedness, response, recovery, and mitigation is similar to how we think about seatbelts and seawalls and even the coronavirus. And so I'm going to talk about some of the technologies, information systems for managing risk. I direct a national congressionally authorized center, the National Disaster Preparedness Training Center, that is funded by FEMA. And we have a focus on natural hazards. So we look at tsunamis, volcanoes, but also technology. We do a lot of work with other universities, a consortium, the National Domestic Preparedness Consortium. And our center in Hawaii trains approximately 8,000 to 10,000 people per year. The consortium, which includes Texas A&M and LSU, New Mexico Tech, and several other organizations, together, we've trained almost 3 million first responders and emergency managers across the nation since its inception. I'm also the director of a project with USAID and Mercy Corps. It's the Invest DM strategy. This is actually phase 2. Phase 1 involved doing an assessment of some of the training needs. This project is about supporting disaster risk reduction and resilience at the national level, provincial, and local levels with NGOs as well too. And we're interested in integrating both in-service training as well as pre-service academic training, and to improve emergency management, data management, communications, and so forth. So if you look at us here in Hawaii, we actually are the closest to Indonesia of any part of the United States. We're also an island state, and we have 2 volcanoes, or many active volcanoes on one of our islands. And again, I think you're familiar with many of the similarities and common threats that we share. You know, when I first started work in Hawaii, the volcano started erupting many years ago, and the Kilauea volcano is one of the most active volcanoes in the world. This is from the 2017 eruption. This is why we developed a drone class for FEMA, because of the hazard materials associated with this. This is actually a solid waste transfer station, which was overtaken by the lava. And we use this as a testing site, as a way of, you know, protecting the critical infrastructure, but also for training different types of, using different types of tools and methodologies. You know, the other big volcano is Mauna Loa, which actually at one point was threatening the city of Hilo. Mauna Loa is perhaps best known for the observatory. And this is where Keeling started monitoring CO2 emissions. I have this small vial, you know, that has air from the top of this volcano in Hawaii to remind us of the stressors associated with climate change, the increase in not just CO2 emissions, but as the previous presentation described, many other greenhouse gases as well too. There are also recent IPC reports, the 6th assessment, which again points out that many of these disasters are increasing in terms of the frequency and the intensity, rapid intensification, which I'm going to talk about, but also it's very widespread, and we are all globally linked because of these impacts to the Arctic, permafrost, and then the impacts on sea level rise combined with the effects of subsidence. Maybe that's due to groundwater extraction and other natural processes. And this has required the use of protective devices, not just seawalls, but also better warning systems and other strategies for mitigation and adaptation. A lot of my research these days, though, focuses on designing with nature. Instead of building seawalls or building structures, trying to use planning and setbacks, elevation strategies. I mean, even looking at things like floating cities as an approach for hazard mitigation. I know too in Indonesia that there are these same challenges that are being faced, and strategies to try to build protective devices. And I think at some point we have to identify other approaches, other strategies that I want to talk about. One of our projects actually involves monitoring over the long term the changes in these coastal areas. And what we're trying to do is, in addition to using traditional engineering and surveying techniques to measure the changes in terms of the erosion and the coastal processes, we've strapped these video cameras into the trees, and we use machine learning algorithms to be able to detect the wave heights or the debris line or other sorts of characteristics to monitor and better understand. And we integrate this, with our drone activities and other work as well too. I think that there are many new technologies that support coastal hazard mitigation and adaptation. And part of what our center does, what our work does, is link these different technologies together and develop new applications. And I want to describe, some of them for you. One of the most important is the integration of mobile sensors in real time to get crowdsourced information, but other detection devices that our hand phones and other devices can use. What I want to do right now is, this is the work I've been working on for the last 2 weeks. You've heard about Hurricane Ida, which is in part, it was driven by climate change. It was a big storm. Fortunately, while the estimated losses were still very large, 25 billion to 35 billion, and compared to Hurricane Katrina or Hurricane Superstorm Sandy, it's a smaller event, but it's the latest big event that we've been focusing on. There are a couple things that are really relevant to our discussion here. One of them is the rapid intensification and acceleration of the wind speeds. This is a problem that we've seen with other storms, and it makes forecasting and the measurement of impacts very, very challenging. So that's something that we've been studying. Of course, with a high wind event, you're likely to have a lot of storm surge. We're estimating with different models the storm surge. This is a complicated storm. That's one of the things about cyclones or hurricanes, as we call them in the US, is that they have multiple types of hazards with them, not just the high wind events, but the storm surge, but also the very heavy rainfall that can come as well too. So the challenge with this was not just the rapid escalation, but it actually lingered. It stayed for a long time with high wind and did a lot of damage to the electrical system, to the communication system. And so this is part of our work monitoring this, the power outages and the losses that are associated with that. You know that if you lose electricity, you lose many, many other critical infrastructure systems. So that's very important. Part of this work relates to the work that our center does in supporting FEMA, and we have systems for both public infrastructure support as well as support of households and families. And I think that that's the challenge that exists. A lot of the work that we do relates to damage assessment, both the kind of preliminary estimates done based upon model inputs, estimated weather information in terms of wind speeds and tracks. And then we also then do actual visual inspections, combining together satellite, air imagery. And then I've sent teams to Louisiana, and I'm going to show you some of the imagery from that. So there were a couple of different areas in southern Louisiana. The storm made landfall close to Grand Isle. So there was a lot of damage that occurred to this area. So I sent our damage assessment teams to Grand Isle. The other thing that we've done is integrate social media and crowdsourcing, both to confirm some of our modeling data, but also to get real-time information. And part of it is, how do you check this and test for the accuracy and the quality of the data? And so, well, that represents a challenge. And so part of what we've been doing is taking all of the different sorts of tweets that are relevant to this, and then trying to identify the locations and the confirmation of whether or not this is really useful and actionable information. We have a lot of other baseline data. We run the HAZUS model. We train many of our students, but also government officials in terms of estimating the underlying population risk, or where the children and elderly people may live, and then where perhaps the minority communities, the underserved communities may be living. We also look for households with disabilities or that don't have transportation that we may have to go and rescue. And then with these tools, we can do pre-storm damage estimates. And what we're doing in our research is comparing it with the actual damage assessments and how well have our models performed and so forth in terms of the requirements, the estimated displaced households, the shelter requirements, and then also the debris. We did for FEMA a debris management course, and part of that's based on actual observations in addition to these sorts of modeled approaches. And part of what we're trying to also really focus on are these critical infrastructure systems. What I want to do is take you quickly through some of the imagery that my team captured in the last week or so. And so what we did was we integrated the aerial imagery that NOAA flew with, Google Street View has 360 imagery. And obviously we concentrated on facilities like power stations. So the bottom, it shows what Google Street View from 2020 shows. And this was last week's imagery from the same cameras that Google has. So what we did was we did this from September 12th through 13th. We're using an NC Tech pulsar camera that's mounted on a vehicle and then driving through that area. So you can look at the before is the Google imagery, and the after is our imagery. And you can see really the dramatic differences. And so we use this for damage assessment and supporting the work of the emergency responders, as well as those involved in debris management and cleanup. And then our other work that we do, my lab, the Pacific Urban Resilience Lab, is developing machine vision algorithms to be able to identify and classify objects collected either by satellite imagery or by our social distancing. And part of what we've had to do because of this crisis is repurpose a lot of these same technologies to address the COVID pandemic. And I think there's an important connection between climate and COVID and some of the lessons that are associated with this. So we are taking the same tools that we have, the machine vision tools, and using it to detect whether or not people are wearing face masks in public locations. This is an example demonstrating, whether or not, one of my grad students is masked or unmasked, or the distance that people are maintaining in public spaces. Because we know that the disease was spread by the movements of people, both into communities and within communities. And so what we're looking at and modeling are the impacts of travel, of reopening the economy. What is the effect on the cases over time? I edited a journal called Transportation Research Interdisciplinary Perspectives, and we published now more than 80 papers on this, on various aspects. And the most interesting thing is the connections between climate change, doing more outdoor activities, green infrastructure, and ways of reducing the wildlife-urban interface to stop the spread of zoonotic diseases. So a lot of the mathematical work that I'm doing involves modeling the likelihoods of the disease spread and using various models to predict who's likely to get it, and it's a function of travel. And basically, we need to fight the pandemic like it's a wildfire, and by that it means using technology, testing, contact tracing, tracking apps, and technologies that really supported by training to really attack this system. A lot of the work that our lab has been doing has been related to contact tracing exposure notification apps. And we've developed different systems with partners. I went to MIT for my graduate education, and so we've worked with many of the same tools and developers that have been developing these systems, and I think this is part of the solution. So we have to really look at best practices, and I think Korea. I noticed there are other people from Korea presenting. I think that there's some lessons to learn about the management of the COVID pandemic, to invest in testing, to do things like, use physical separation, innovative systems for protection. I mean, Korea did before anyone else the drive-through testing, and that protects both the screeners, but also those getting tested, and much better smartphone integration and sharing of public health data, and really flexible systems, as opposed to just locking down and closing businesses. It's really interesting. My brother-in-law was visiting me in Hawaii, and when he went back to Korea, he was really supported in terms of the mandatory quarantine restriction. I mean, they sent to him a big box of food. They checked in on him periodically. And I think that that's the kind of support that you need in order to combat this disease. Prior to the pandemic in Hawaii, what was the greatest threat, according to the Department of Emergency Management, our state? Well, it was the attack from North Korea. That was the greatest threat. Actually, we were doing all this preparation, but it actually led to a false alarm. There was a statewide message sent out on January 13, 2018, that Hawaii was under attack. And that caused a lot of unnecessary trauma and panic. It also shows us something else really important, that technology itself can be a threat or hazard, and that we need to manage it and understand it and train for it to avoid these kinds of disasters. When I think about the nuclear threat of North Korea, I'm reminded too of the biggest disaster in the Asia-Pacific region, the Fukushima disaster. If you look at long-term environmental impacts, but also economic impacts. And so this is one of the disasters that I have studied very, very closely. And it also points to the limitations of traditional engineering approaches. Remember, the Fukushima power plant had big seawalls. It had deep setbacks. It had elevation. It had backup generation. It had planned for conceivably the worst case scenarios, right? And we know what happened with that. And we know what the ongoing problem is associated with this, is that they've run out of alternatives now, that they're planning to release millions and millions of tons of contaminated water into the Pacific because they've simply run out of space to store this. And so that represents another threat and hazard that I don't believe was adequately addressed, and that we as a community need to come together and work on. So I would like to close by, again, drawing upon my experience in Korea. I was quoted in Time magazine once about this project. This is actually a first generation attempt at combining, flood risk management and green infrastructure. This, of course, is the Cheonggyecheon stream restoration project, which took an elevated highway with 138,000 cars per day and got rid of it and restored a stream there. Actually, when you look at this, this is an over-engineered project. I mean, it is a good first generation attempt at doing this. But there are a lot of problems with it. How much water it uses, the need for artificial pumps, the many sort of challenges and lessons that we've learned from this. But I think the idea behind it, to go green, to try to design with nature, to try to accommodate nature, I think that that's the way we should approach hazard mitigation and long-term adaptation to the challenges and threats and hazards posed by climate change. And so I want to thank you all very much. I do hope that we can collaborate and continue to work together. And I look forward to seeing you all either in Indonesia or perhaps in Hawaii. Thank you.
Thank you very much, Professor Kim, for the excellent talk. Now we move on to the next session. The organizer give me chance for 1 or 2 questions from the audience. If you have questions, please raise your hand. You may ask Dr. Ada or Professor Kim. Only 1 question for each presenter because we are limited in time. So no questions from everyone? Okay, let me try to trigger a question from other participants. Professor Kim, I have 1 question for you. I have been in Big Island in Hilo in December 2019, and I witnessed about the impact of the eruptions. So you presented about the impact in terms of economic things like for human and then social, and also about the environment. But my question is about the impact for resources in terms of the natural resources, like the plants, the forests, and then also the marine resources, for example, like in the coastal area. Can you explain to us about the impact? Then, did you quantify the impact for the resources in Big Island, for example, or in Hawaii in general?
That's a really good question. I mean, this is the volcano disaster was one that we studied and we're continuing to study because more than 700 homes were destroyed in about 3 days. So it's a very large disaster. In addition to that, we have a geothermal plant that was also, sections of that was destroyed. And that was a problem because I think it provided something like 10% of the energy for the island. And so as a consequence, they had to switch to burning fossil fuels until that geothermal plant was repaired. This area is actually, it's the most active area for volcanoes. And so what's really fascinating about this is that people know and understand the risks. I mean, it kind of reminds me a bit of Merapi when I visited Merapi several times, and that people understand that this is the risk that we have to adapt to. And I think that communities that live with active volcanoes are in some ways better prepared to understand the threats of climate change, of sea level rise, and other hazards and threats. And I think one of the big problems, obviously, of course, and this relates to planning and zoning and so forth. We know that this is the most dangerous area in the state, but at the same time, too, it is the fastest growing in terms of population. Why? Because the land prices are so cheap. Because the land prices capture the value of the risk and the threat. So many people want to live there because they want to live in Hawaii, and they believe that, they're willing to take the risk. But the problem with this is that once all these people move there, then you have to start providing services. It's not just roads and solid waste transfer stations, but it's also schools. And then once you start bringing in schools and other types of activities, you start bringing in grocery stores and drug stores and, all kinds of other types of activities. And then before you know it, you've absolutely lost control over the growth and development. And that's one of the really powerful lessons, I think, to be learned about how to manage risk and disasters. Obviously, the more that we can do to take advantage of not just the geothermal resources, but other natural assets, I think it's very important. And I want to invite you back to Hawaii because again, I think I think islands like we have here in Indonesia and in Hawaii, we have so much to share because it's not just the common hazards and threats, it's the way our communities and societies work. And that's why I think we have such a great partnership and hope we can continue. Yeah.
Yes, agree, Professor Kim. Yes, so people may call you like a Dr. Disaster, but in this conference, we call you Professor Sharing of Knowledge.
Okay, thank you.
Yeah. So, thank you very much, Dr. Ada and Professor Kim, in addressing this interesting topic. On behalf of the organizer of the conference, we would like to present each of you with token of appreciation in form of official certificate. Organizer, if you prepare the certificate, official certificate, can you share and then show to all of us here? Please give a roundabout applause to the excellent speakers today. And the second one for Professor Carl Kim. Yes. So that is the end of the keynote speaker today. Thank you all for participating in the session. Now I give the time back to Ms. Rina Yowei, the MC. Thank you.
Thank you very much, Professor Ricardo, as well as thank you very much, Professor Dr. Kim and Mr. Ardasena for, I would say, very enlightening, informative, and insightful presentations. Once again, thank you very much. Ladies and gentlemen, the next will be hearing the presentation from our expert speakers. The expert speech will be delivered by Dr. Lee Han-soo from Hiroshima University, Japan, Professor Dr. Sung-soo Lee from Changbak National University, Korea, Professor Juan M. Pulhin, PhD from University of the Philippines, Los Banos, Philippines, and joining in this session, Dr. Raditya Jati, SSE, MSE, Deputy of System and Strategy Badan Nasional Penanggulangan Bencana. The expert speech will be moderated by Dr. Elizabeth Wambrau. To Miss Elizabeth, time is yours.
Well, thank you so much, Miss Rina. Yeah, before we starting, is Pak Raditya already here? Hello, before we starting.
Yeah.
Yeah, is Pak Raditya. Okay, yes.
Selamat pagi.
Okay, yeah, good day. Yeah, well, thank you so much, all the participation. We will, the first one, we will welcome to you for UF DRR conference. After we have the first season by moderator by Professor Ricardo with Pak Ardesana and Prof. Kim, really interesting speech. Yeah, I mean, like we all enhanced by the knowledge. Now this time we have really lucky too because we have 4 outstanding speakers. The first one is like Pak Raditya from the NPB, and the next one Prof. Lee Han-soo, and then Professor Sung-san Lee, and then the last one from Juan Pulhin. Well, ladies and gentlemen, for this session, I will split into 2 sessions. The first one we will have listen from Pak Raditya, and then Professor Lee San-hoon. Okay, for the first one, Pak Raditya Jatinegara is a Deputy of System and Strategy from BNPB. Will be present the role of BNPB on activating pentaholics for climate related to hazard in disaster. So for the time, we will give the platform for Pak Raditya for sharing his knowledge for us. Yeah, the time is yours, Pak Raditya.
Thank you, Elizabeth, for the time. I'm really sorry for the background of the noise. So first of all, I would like to thank you for inviting the NDP, the National Disaster Management Authority, for this important conference of the University Forum for Disaster Risk Reduction. I think this is one of the good issues on the climate change, and also will be one of the primary mover of the research and technology for the university to be in technology. So we really thank you on behalf of the BNPP, and I'm really sorry that the head of BNPP cannot make it for today for this speech, and I'm really sorry also for the late time because I was on the plane. So if I may share the screen for today. So sorry. Share the screen. Let me see. Oops. Yeah. So today we're talking about how can we coordinate among other helix or stakeholders on activating the climate-related hazard. Our data since the 23rd of September, we have more than 1,900 frequency of disaster, and most of them, 98%, are due to the hydrometeorological impact. So I think this is one important to discuss, especially from the university and from the expert. How can really deal with the disaster due to the hydrometeorological and the climate impact? So first, I would like to share the understanding of disaster risk itself on building disaster resilience. As you might know, Indonesia is a ring of fire, and we have a higher risk. And we can see that more than the 60% of projected population included Indonesia derived from hydrometeorological disaster. And also the threat of the non-natural disaster. This is now we're dealing with the pandemic itself. Indonesia is a vulnerable disaster also that you can see changes of the rainfall. You can see the first resource person from the MKG mentioning about how we are vulnerable of the flood slide. You can see also how is the you can see Seroja that also hit NTT, Nusa Tenggara Timur, at the court because of flood, landslide, and strong wind. I think this is one
Halo Pak Raditya.
and how we
Yeah, probably Pak Raditya have a poor connection.
Yeah, sorry for that.
Sana.
I think there's a problem for the yes. Okay, now I'm back. I hope you can hear me all. Okay, so this is one of the cycle that we have to deal with it before the disaster happened. And we're talking about when during disaster, so we're responding to the disaster itself, but before the disaster happened, we have to deal with the risk. So this is what we're now dealing, how we can minimize the risk itself due to the global warming, change of season pattern, rainfall changes, extreme weather variability, and the threat of change itself. So once we know that 7 of the 10 of the type of disaster, the NDP had they have the data that due to that is due to the climate-related disaster, which means this is flood, flash flood, landslide, drought, extreme weather, extreme wave abrasion, land, forest fire. So we're not talking about earthquake and tsunami, but we're once the data for this 14 last year, we're talking about 98% of the data is due to the high climate change. And if you might see, this is what the disaster happened in the projection from the MKG. I think we're dealing with how we can deal and how to relate to the people surrounding and how to plan itself until 2040. So we have to have the incorporation of the whole agenda, the global agenda from the SDGs, Sendai Framework for Disaster Risk Reduction, the COP21, and also the Financial for Development in Addis Ababa. I think we have to have a midterm national development plan until that time that we have to deal who can really take the responsibility and how can we really deal with the disaster itself and how to manage the disaster. So how to manage the risk. So the change paradigm from the Sendai Framework is not only dealing how to manage the disaster, but how to manage the risk itself for the disaster. So the impact of the climate and hydrometeorological that happen in Indonesia had also increased the poverty level, which means also impacted to the livelihood of the people, including food production. I think this is a very important issue that we have to deal, and we can see how many trillion of rupiah that have been caused by the forest fire since 2018 and 2019 is also reduced. But I think the cycle is also not only damage in the forest fire, but also impacted to the ecosystem and also to the health of the people. So, distinguished guests, ladies and gentlemen, I think this is how we deal, how to measure, and how to calculate the Indonesian Disaster Index. It's also we can calculate the economic growth of the center considered the high risk itself. And you can see in the map, we calculate every year since 2013 as a base map. Now we can reduce the risk itself. How to do that is how to raise the capacity, including also science and technology have their role to play the portal of the, to show the data and also how to measure and how to surveillance can be dealing with the disaster and disaster loss database. So once we have the data, the information, and also the analysis, then we can do the climate change adaptation are now contained in the master plan of disaster we have the 25 years plan in 2010. The present 5 years we can base that we have the DP or disaster bencana Indonesia, and we can call it the data is the integration of the main data that is also brought up to us, including the MKG and also other line ministry, how to integrate this data and how to put it into information that can we deal with that into various of level, including from level from the district, provincial, and also to national level. And how we can really deal with the data and we disaggregate the data and to put it into data field into each location, and we put it into the time series of data. I would like to show you how the INARIS had now been doing since 2016. We have launched the INARIS, which include the potential hazard, population, physical loss, economic loss, environment damage, and tools of the disaster risk index itself. So the INARIS is now you can open it into, it's open source as a platform with other line ministry putting into one data, into one platform, and we can also know how can we calculate the data and also to see it as spatial way. So, and we can overlap it with what kind of data, disaster type, the assessment overlay, and also how can we see the hazard map itself, and how we can also integrate with other related to facilities, including infrastructure, critical infrastructure, for example, schools. We also integrated with hospital and community services and so on. And despite we also calculate how INARIS can also open calculate the resiliency itself in each district. And now we can also have the DB in geospatial. You can open it in the website of BNPB. We also use INAWare, INASAFE, and how to calculate that. We also have this application that we can download it and everybody can access it. How risky am I? This is a personal way. You can also know where are the schools, and now we're counting also the COVID-19, where are the area that is also vulnerable for us, and the hazard and the risk itself. So now I would like to share the long-term planning that we have in 25 years until we have shown that the collaboration of each line ministry, not only line ministry, but also included the pentahelix, what we call it, including the academy or university, including the private sector, NGOs, and also media and the government. We also really deal with the Indonesian disaster management planning 2020-2040, which also included the disaster management plan as a plan that is covering the whole nationwide. And this is a plan that is and put it into the 5-year term plan as how do you say, as a base for the subnational level, including the province and also the district, to develop their plan in every 5 years. So how can we deal with the national plan and the district plan into one, synergized from the national to local level, since we are now decentralized government? So we have to have the same spirit to have the plan until the 25-year to reach the national resilience itself. The vision of the disaster management in Indonesian disaster management plan 2020-2044 is to have the realizing of disaster resilience. Means that Indonesia is able to withstand, absorb, adapt, and recover to affect the disaster and climate change in timely, effective, and efficient manner. So plan for the long-term plan. You can see 5-year achievement. How can we deal with the integration of the whole nation to the political level, and how to deal with the convergence of the climate change into disaster risk reduction itself, from the climate into the disaster, and to put it into one issues of the DRR and exposure, vulnerability, and weapon. So, distinguished guests, ladies and gentlemen, climate change adaptation and disaster risk reduction had put it into the content of the climate change itself to increase the frequency of intensity of climate-related hazard, including long dry seasons, and also how do you say? It's not only for rapid onset disaster, but we are also talking about slow onset disaster. So the paradigm shift is now how to prevent and mitigate the climate-related disaster, including how the community resilience, including the livelihood, the safety, to ultimate their goal. So I think the climate change adaptation in the term of the driving force as reduction of the factors. So I would like to show how the movement now in the community level since 2017, we have the movement to show that the people now are moving. This is what we call the pentahelic, and all the government, the academician, the private sector, NGOs, and also the community, also the media had synergized together with coordination, command, and implementation, how to put into one program the role of the pentahelic climate change adaptation, also to identify and to build the ecosystem-based DRR and the capacity of the people and building awareness. So I think one of the movement now we're dealing with, and I think also it's not only mitigation, but we also put the structural mitigation into the program for the community level. So this is what we have to share you all, and we are now also have the responsibility to report to the global UNDRR or United Nations for Disaster Reduction for the Sendai Framework for Disaster Reduction, that we have put it into the framework. At that time, Indonesia had proposed Indonesia as an archipelagic state have more risk than rather than other mainland. So I think most of the countries that have islands and also coastal line is very important to have their understanding on risk, especially in the coastal line, which many cities, big cities, are located in the coastal line. So this is the target that we report every year, and we have to put it that in and as an input for the SDGs. So as a closing remark, I think one of the plans that we have to put into pay attention is how to reduce the risk itself, including how to put into climate change. The collaboration and also the synergize of the policy, institution planning and funding have to be effective from central to regional level or subnational level unto the district, including the capacity building of the region and commitment of the stakeholders, including commitment of the leader and also governor and mayor and also bupati that have to have their plan, mainstreaming DRR into the plan. So I think this is what I have today. And once again, thank you for the time of inviting BNPB for this important seminar from University of Papua and also Forum Perguruan Tinggi, or we can say University Forum for DRR. Thank you once again, and have a nice day.
Well, thank you so much, Pak Raditya, with a really, really amazing speech. Before we have Pak Arden Sena from BMKG who talk about the indicator to record the indicator of climate change. And then the second, we have really amazing from Kim from Hawaii, who talked about the practice that have done in Hawaii. And then we have Pak Raditya from BNPB for government, who talked about tools that integrated all the stuff to manage disaster in Indonesia. And then by making one data, so all the stakeholder can be together to solve the problem of the disaster. Yeah. Pak Radianto, do you still have time to listen for another presenting? Or if you don't have time, I will give one or question from the audience to ask you.
Yeah, I'm really sorry because I have another agenda. So if I may, I would like to leave, but if there's one or two questions, then I can also wait for that. But I'm really sorry, I cannot wait until the end of the seminar. I'm really sorry, ma'am.
Okay, yeah, well, all the participants, I still just have a lot of patience, yeah, to ask, especially for Pak Raditya. Yeah, it's really rare even to have you here. So probably I only give one person who want to ask Pak Raditya.
Saya, Bu Elizabeth.
Oke,
Oke,
Pak Henry.
Mas Raditya, Pandang Hilmi. Mas Raditya, how are you?
Yeah, okay. Please really brief.
Mas Raditya, maybe I want to know maybe, the rule of collaborating between academic community and BNPB in activity Pentalix system, yeah, for climate hazard adaptation and reduction in Indonesia. Maybe you please, maybe you have smart strategy, maybe. Thank you, Pak Radit.
Thank you very much. This is a very important question, and I think we also endorse the universities. So I think Kang Ete, he is one of the leaders. I think he play a very important role for Unity Forum and handling all getting all the university into one integrated forum, what we call now Unity Forum for DRR. So we have been dealing with that for several years, I think. So we integrate the program, and also we invite friends from university academician into developing policies and also we invite experts also if we have any seminar, webinar. We are also dealing with every month we have what we call the information giving to the public, and we also invite the academician to mention that. We also involve academician and also experts on developing the standard Indonesian standard organization and what we call the standard organization by BSN and also ISO. So I think we have a good engagement from the government and also the university. So I hope we can deal with that for the next future, and we're open for any other how do you say, suggestion, proposal, and what can we collaborate together with the academician, together with BNPB to reduce the risk and handling and to save more life, reducing casualties, reducing social economic impact, and also reducing the damage of critical infrastructure. So I think university play important role. Thank you very much for this important question.
Okay, still important sector.
Very,
Thank you, Mas Radit.
very important sector from the academician.
Yeah, well, thank you so much, Pak Raditya. We know that you have really limited time, but as a part of appreciation us for you, we will give you a certificate. But I ask all the participation, can you 2 seconds to unmute your microphone speaker, and then we give applause for Pak Raditya, Prof. Kim, and Pak Adesana. Yeah, thank you. So make sure that we still focus in the certificate. Thank you so much, Pak Raditya. This is a great pleasure for us, especially for academic, to improve our engagement with BNPB. Thank you so much, Pak Raditya. Well, thank you.
Thank you.
Okay, ladies and gentlemen, after we listen from the Pak Raditya, we still have a lot of we still have three more expert speakers who really expert in his them field and then want to share with us. Okay, now I will introduce you to Professor Lee Han-sun. Professor Lee Han-sun, are you there? Yeah, he is a professor. He is a professor from Hiroshima University. Nice to meet you, Professor Lee.
Hello, nice to meet you too.
Nice to meet you. He is an expert in coastal engineering associated to storm surge, tsunami, wind wave, typhoon. And then his background, he earned for undergraduate and master graduate in civil engineering from Sun Kyun-kwan University, Korea, and then earned his PhD in Kyoto University. And then today he will share knowledge about multi-model assemblies wave climate projection in the Western North Pacific. Prof. Lee, I will give you time, probably 15 minutes, to share your study for us, and then I hope you will benefit a lot. Thank you. The time is yours, Prof. Lee.
Okay, so can you see my slide?
Yep.
Okay, thank you for the introduction. And then, first of all, yeah, thank you for having me in this nice conference. And then also good to see my old friend, Dr. Henry. Also, I was surprised to see Dr. Sena from PMKG because we are in the same project, working in the same project. Okay, so in the previous talk, the invited speakers, they are rather talking about broad aspect about disasters or challenges due to the climate change, etc. But today I'd like to give you, sorry for that. Sorry. I'm very sorry for the interruption. So I'd like to talk about rather what the specific subject about the multimodal ensemble wave climate projection. Since the wave is very important physical phenomena in the ocean that are affecting many of aspects of our life and then activity in the ocean. So especially focusing on the wave climate in the Western North Pacific using some multimodal ensemble external forcings from CMIP6. Okay, so I will make a fast talk today. Okay, background. So the ocean wave, especially I'm talking about the wind waves, are very important in the marine activities and then many related activities in the oceans. And then at these times in the global scale, the waves we know that play an important role in climate changes via CO2 release and absorption through the wave breakings between the atmosphere and ocean. This is very important interface between the atmosphere and ocean. That is very important in the climate projections, etc., climate changes. And then also, but at the same time, we have some questions, major questions, how the climate changes impact the ocean waves, and then how the waves have been changed over the last centuries, and then how the waves will change in the future simply. But more specifically, we have more scientific questions as here on the how, if the waves are changing in the future, then how much of these future changes can be predicted, and with which level of confidence, and whether the changes are due to the natural variability of the climate or the changes due to the anthropogenic effect has to be investigated, even though it's quite difficult to distinguish between them. Therefore, the studying the future wave changes and the wave climate projections and its uses in the wide range of application are very important. Also, the future wave changes and wave climate projections has been studied in many. Actually, we have nowadays many studies are reported, and then they are using the high quality wind data set. Since we are talking about wind waves, we define temporal and the spatial resolutions, and then they are required. Also, the analysis data set and remote sensing products are commonly utilized for the past and present. For the future, sorry, can you hear me?
Yes, we can hear you. Please continue, briefly.
Okay, so for the future climate projections, the many researchers are using the coupled model intercomparison project CMIP data set, and which is available from IPCC data archive. So regional and global scale marine surface wind from CMIP and CMIP3 and CMIP5 was mostly used in the past studies. Therefore, based on this background, the objective of today's talk are evaluate the marine surface winds from the most advanced CMIP6 data set, specifically over the Western North Pacific. And then first, we reduce the biases in the marine surface wind that is included in the CMIP6 model data set using the 3 different bias correction method. And then we quantitatively assess the future wave climate in the Western North Pacific using the CMIP6 marine surface wind. So study area, we focus on the Western North Pacific. Needless to say, we have this Western North Pacific is very important in many aspects. As you see also, we have most of the tropical cyclones that are generated in the Western North Pacific. And then we have many shipping and navigation activities here. And then specifically, this area is set as the study domain. And then we further divide the 4 subdomains: Japan East Sea, and then East Japan, Southeastern Japan, and then Southern Japan to investigate some more detailed wave characteristics at each sub-regions. And then first of all, we collect the CMIP marine surface wind data set, especially from CMIP6 archive. So we collect the marine surface wind for the study domain from the 78 ensembles, quite many ensembles actually, for the 30 years from 1979 to 2008. Also, to compare with the qualities of the CMIP6 data set, we also at the same time collect the marine surface wind from CMIP5 from the 72 ensembles. Also, to compare or evaluate the marine surface wind of the CMIP data set, we use the reference data set from the ERA interim DRR data set from ECMWF. Also, we use nowadays the ERA 5 DRR data sets. Then the bathymetry and the coastline data set are used from these data. Then overall process is like shown here. first of all, we collect the marine surface strain data from CMIP6 and CMIP5, and then we evaluate the such marine surface for the 30 years from 1979 to 2008, and then we, by comparing with the DNS data set, we correct the biases of the winds, and then after that we calculate the wave climate projections. But first of all, we calculate the wave climate for 2000, and then compare that validate the wave characteristic with the DNS data set for the 2005 from ERA 5, and then next we calculate the wave climates for 2050 and 2100 under the SSP 4.5 and the 8.5 scenarios. Then we use the 8 ensembles for the marine surface winds. Then after that, we calculate the wave climates. Then we calculate the wave characteristic from the individual ensemble results. Also, we calculate the ensemble mean results. This is the overall procedure. And then this is a more detailed procedure, so how we evaluate the marine surface wind, and then how we correct the marine, wind biases, and then how we project the wave climate using the WaveWatch3 model version 5.616. Then we use these 5 statistical indices to evaluate the model performance. Then also these 3, the variance scaling operation, and then quantile mapping based on empirical cumulative density functions, and then quantile mapping based on variable distributions are used for bias corrections. So this is a result for the marine surface wind evaluations. So for the study domains, we calculated these kind of statistical indexes, and then each circle, and then the sizes are indicating the degree of the R-square value. Then the colors indicating like that, and then size is also color indicating the wind speed biases. We can find that most of the highest and lowest statistical indices appear near the coastline, between the strait between the China and Taiwan, and then Taiwan to Philippines. So we think this is one of the reasons is the low resolutions of the GCM data set. But anyhow, over the sea surface or the ocean in the Western Pacific Ocean, most of the marine surface wind from CMIP data sets are overestimated compared to the CMIP, the reference data set, ERA interim and the ERA 5. Then we also calculate the model performance using the performance shown by using the Taylor diagram. And then these are the individual ensemble values, and then these 2 are showing the multimodal ensemble mean value. So as we can see, or somehow it's obvious nowadays that the multimodal ensemble mean performs better than the individual ensemble in terms of wind qualities, marine surface wind qualities. And then further, we investigate the wind characteristic over the subdomains in the Japanese Sea, Eastern Japan, Southern Japan, and Southeastern Japan. And then especially the zonal wind in the Eastern and the Southern Japan performed well when we compare the reference data set and then multimodal ensemble mean value during a year from January to December. But in Japan East Sea area, we can find some high wind biases, especially during the winter seasons when we have a strong north or northeasterly winds from the Siberia to the western North Pacific. And then also in the southeastern wind, Japan also we have a slightly higher high wind biases. When we look at the meridional winds, we also find that southern and the southeastern Japan subregions are showing good performance in terms of multimodal ensemble mean. But in Japan East Sea area, we also have high wind biases. When we look at the wind vectors from the CMIP6 multimodal ensemble mean shows quite good agreement generally. Then further, we compare the 30 years monthly average wind for the study domains. Then this is the ERA interim, the reference data set, and then this is the differences between CMIP6 multimodal ensemble mean and ERA interim real-ness data set. So that we can see that wind biases are distributing from negative 1.5 to a positive 1.5. And some areas are overestimated overall, generally over the Western North Pacific. And then these three chart panels, it shows the difference after the wind bias corrections, applying the bias correction method. So that if you look at the color bar, the ranges are much reduced from the original differences. So that, and then especially when we apply the quantile mapping based on the variable distributions, the errors are much reduced compared to the original differences, and they even compared to the two different methods. If we look at the relative frequencies of the wind bias distributions, before applying the bias correction method, the wind errors biases are rather evenly distributed from the negative 0.5 to the 1 meter per second. But after we apply the wind biases, the biases are the bands of the wind bias are much more narrowed, and then the bias correction with the variable distribution shows that the errors are much reduced, and then as we can see in the chart. Then this chart shows the validation result of the wave climate project simulations for the 2000. So we compare the wave 3 modeling result in the left column, and then in the middle column, these are the reference data set for error from the error 5 reanalysis, and then these right columns show the difference between the model and then a reference data set. And then first row is indicating the significant wave height. So the middle indicating the mean wave direction. The bottom indicate the mean wave period. So overall, it performs well, but some of the sub-region in the study domains are over or underestimated. For example, the mean wave directions in this part, so the southeastern part, are much more overestimating. That means the wave directions are more rotated in the clockwise. Also, the wave height in the southeastern part are underestimated, like approximately between 0 to 0.5 meters. The mean wave period in the southeastern or the eastern part of the study domains are underestimated, between 1 to approximately 1 second. Then now we show the wave climate projection result for the 2050 and 2100. The left-hand side shows the result for the SP2 4.5 scenarios. The upper row, and the bottom shows the result for the SSP 5 or 8.5 scenarios. Now for 2050 and 2100. By comparing to the result to 2000 significant wave height in 2000, overall in the open Western North Pacific, most of the areas are showing that wave height is decreasing. In the coastal areas between near the Korea and Japan, we have wave height slightly increased under the 4.5 scenario in 2050. Also in the East and Japan Sea, we have the wave height that slightly increases in 2100. But if we look at 2100 under the 8.5 scenarios, most of the areas are all the wave heights are decreased between 0 to 0.5 meters. These results are showing quite a good correlation with the previous studies, but when they use the more low resolution wave projections. Also, this one shows the wave climate projection result for the wave directions. And then most of the sea areas, even though there are some variations, but most of the Western North Pacific shows the overestimation. That means the wave directions are changing into the clockwise direction. Clockwise is in these degrees, between 0 to 30 degrees or less than 30 degrees in clockwise. Then this is also showing the somehow good agreement with the previous studies. And then this is show the wave climate projections for wave period. And then most of the Western North Pacific areas are showing the decreases in wave period between 0 to 0.5 seconds or so. Also, it shows the other researches by Hemo et al. Show the decreases of the wave period between 0.25 to 0.25 degrees seconds. So this slide shows the maximum significant wave heights. That is for 2000, 2050, and 2100 under the different scenarios, then the maximum significant wave height in the southern part of the study domains are decreasing compared to the current situation, climate, but also the wave height in the northern part of the study domain, the northeastern part of the domain, which is the western part, western north of the western North Pacific, are increasing due to the increased wind velocities. That also some of the studies are indicating that these areas are quite vulnerable or are sensitive to the wind waves, are sensitive, especially the maximum significant wave heights are sensitive to the typhoon or the tropical typhoon passes. So it is closely related to the frequencies and the intensity tropical typhoons in the future. So the conclusion is that we compare the wind qualities, marine surface wind, between the CMIP 6 and then the previous version, CMIP 3 and 5. They are not really significantly different. And then we apply the bias correction method to evaluate and then reduce the biases in the marine surface wind. And then quantile mapping based on Y distribution show the good performances by reducing the biases quite much. And then this is an important finding of our study. One of the significant wave heights are overall decreasing, but some parts of the study areas are increasing, but overall so like decreasing. And then wave directions are shifting in the clockwise directions, more further between 10 to 20 degrees, and then wave periods will be reduced between the 0.25 or 0.5 seconds. And then extreme significant wave height can reach to 18 meters or in the open northern part of the western North Pacific. That's even because of the study domain is only focusing on the western North Pacific. So if we consider the whole Pacific Ocean, then significant wave height are increasing the northern part of the Pacific Ocean. Then these findings are in climate. Wave climate changes in the western North Pacific shows a good coincide agreement with the previous published papers that are using the CMIP 3 and the CMIP 5 results. And then these what kind of wave climate projections are useful in many related marine activities. Also, we are now focusing on more further downscaling, focusing on the wave climate changes in the coastal regions, such that we can use such information for further studies of coastal erosion, etc. Okay, this is a limitation and further researches. I will skip it. And then these are the papers that recently we published the related contents in this journal. So if you are interested in, you can have a look more details from the paper. Thank you very much.
Thank you, Prof. Lee. Really interesting, but actually really technical in coastal engineering or tsunami. Probably Pak Henry, the expert, will be collaborate by Pak Lee. Okay, for this time, Prof. Lee, probably we will give the time for the participation. Probably two participants who want to ask Prof. Lee, please raise your hand. While waiting for the question, probably I think it's really interesting, because Prof. Lee make a model and then several scenario to estimate the wave climate, like the wave height, the wave direction, and then period, and then extreme. And then I think it's really important for us, especially in Indonesia, because we have quite similar geography that's we dominated by water, by ocean. So it's really important for us, because we can predict the wave, because to reduce the risk of the disaster, and also we can use the wave to potential, probably Prof. Lee, to use as a renewable energy by knowing the oil indicator. Okay, anyone want to ask? Please raise your hand. If no one, probably from the chat. Okay, for Honorable, I give Pak Henry as a committee head to ask Prof. Lee. because he is a friend of Prof. Lee too, so they can reunion. Prof. Henry, Pak Henry, Pak Dr. Henry, please, if you have any question.
Okay, so no
There's no
question.
question. Yeah. Oh, probably I will ask question. Prof. Lee, it's really interesting. So I mean, like, beside your study, it's mean that we can predict the risks if probably in some part of area, for example, the ice in the North Pole is melting, is really influence. You can do the. I mean, like, is related or no?
You mean Arctic glaciers or what?
Yeah, the glacier. Yes, I mean, like, because you talk about the wave, the heads, and then we know that some part will, especially in Papua, will be drawn if the melting, and then it must be related to the wave, to the what do you think?
The ice sheet or some the sea ices are known to affecting the wave propagation. So, needless to say, they are important to physical phenomena. So, if we have a sea ices and then that affect the wave propagation, the wave characteristic, that is known fact. And then today I just talked about the wave climate, but of course, as you can see, though, it's shown that many studies, including our results, are showing the wave climate that decreasing in the Western North Pacific in the future. But now I don't consider any other factors, sea level rise, etc. So since the sea level will keep rising, then the increase the water depth will affect the wave height increasement. So such kind of other factors are not included in the wave climate projection. Further, like even though you don't have a tropical cyclone in Indonesia, but the storms are there. So then the wave climate is very important in many other aspects, in my opinion. So yeah, this kind of study or is important. So yeah, is that clear? Okay, enough to your question?
Yeah, but yeah, it's enough. I will give the time for the audience. Still have any question? We still have a lot of time, and then we are lucky we have Prof. Lee. We should use this opportunity to ask a lot. Okay, probably one another, Prof. Lee. Prof. Lee, now a lot of reclamation in around all coastal area in Indonesia, especially in Papua. So what do you think it will be impact to the wave climate or no?
The reclamation.
Yes, I mean, like,
yeah.
most of area it's reclamation now in Papua.
That means you have beach erosions, serious beach erosion problems, right? Then beach erosion mainly caused by the waves, needless to say, and then wave heights, that increase and decrease of the wave heights, especially the wave directions, are also very important the factors for the beach erosion, and then therefore reclamations or a nourishment of the coastal beaches are all related, in my opinion, and then therefore the wave information is very important. And then the future wave climate, how the wave will changes. I don't know much about the wave climate because I haven't investigated how the wave climate will change near the Indonesian and maritime continents, but it's very useful studies that you have to investigate how the wave climate will change. Then there are many studies about the relationship between the wave height and the wave directions, even period, to the coastal beach erosions. So then those kind of aspects will changes also as the wave climate will change in the future. So I think, this is very important to study, and then definitely we need such kind of some specific scientific and engineering studies to see or to keep your continents or the territories there.
Yeah, thank you, Pak Kim. One opportunity for student. If any student, please, not lecture, not researchers, but student. Probably student, I give you an opportunity. You can ask in Indonesia, it's okay, and then we will try to translate in English, please. No question? Okay. 1 minute? No? Oh, one news message. What is it? Is Prof accept student? Yes, of course. Yeah. Prof Lee, the question is, do you accept a student? Probably you will open research together with a student. It's mean, Pak Setya.
Maybe I can show you.
Mm-hmm.
Can you see my slide or my?
No.
Not yet, not yet.
Can you see my? Oh no, I haven't. Yeah. Can you see my screen? Hello.
Yep. Yeah,
This
yeah,
is,
we can see.
This is website of our laboratory. So if you look at the students, we have many students even from Indonesia. He's from BMKG actually. So then, yeah, of course I accept the students. More than almost 20 students from all over the world. So yeah, if you are interested in, please send me your email. Of course, yeah, I cannot guarantee, but yeah, at least I can consider.
Yeah, thank you. So I mean, like a lot of students, you listen that Prof Lee open the opportunity to use to collaborate because we still are virtual, so you don't have to come to Japan to do, but we can do we can do virtual like this. Yeah.
As soon as the corona.
Yeah, it's Corona. Corona, some things have a disaster, but it's blessing too. So we can do the virtual like this. So it's really reduce the cost.
I think Dr. Henry studied in Hiroshima University. So ask him how is the situation in Hiroshima or the life in Hiroshima. So
Pak Henry, do you mind? You still have time, probably 1 minute to share the Hiroshima and Nagasaki. Last time it's about World War II. Probably a lot of changing, a lot of study.
I don't have the material for that, but yeah, anyway.
Pak Henry want to ask one question.
Hello.
Yeah, hello, Dr. Lee. How are you?
Nice to see you. Long time no see.
Yeah, it's very interesting topic, Dr. Lee. So maybe the next step, we want to make the same research, yeah, with Dr. Lee to know our condition, our wave, and then also current attack to our coastal area, because in the eastern part of Indonesia, very a lot of small islands. In West Papua, we have 4,110, and then also plus to the Maluku and North Maluku become more, maybe around 7,000. Yeah, so this is most interesting. So this climate change is more affected to our area, and then also for the climate disaster. Yeah, this are most important research. So maybe we need to be duplicate in our area. Thank you, Dr. Lee.
Okay, thank you.
Well,
yeah,
thank you, Pak.
Yeah, hope to see you.
Yeah, thank you, Pak Henry, for speaking. Probably next time we will do collaboration with Prof Lee. Okay, the audience just still have time. You can write down into chat if you still not thinking of the question, and then probably Prof Lee can directly answer if its participant, probably some participant put something in the chat. Okay, Prof Lee, thank you for the sharing for today. As a part of appreciation us for you, we give you a certificate. Please, all the audience, we give applause for Prof Lee. Please open your speaker.
Thank you.
Thank you so much, Prof Lee. Okay, Miss Rina, for the time, we will continue to the next speaker directly, or we will have some brief break.
We can continue the presentation and discussion, Miss Elizabeth, please.
We can continue to the next speakers. Yeah. Ms. Rina, so I will continue to the expert speaker now.
Please continue.
Continue, even though already almost 1 p.m. Okay. Okay, ladies and gentlemen, and other participants, I hope you still have what is still have a spirit, still have keep the motivation to continue. Yeah, even though already afternoon, I think we can have a lunch by ourselves while watching the presentation. Okay, the next, the third speaker is Prof. Sung Soo Lee from Chengbuk National University.
Hello.
Yeah, hello, Prof. Prof. Sung Soo Lee. What I call you, Prof. Sung Soo?
Just to call me Sung Soo.
Ah,
that's my
okay, yeah.
given name. So
yeah, give it a name.
Yeah.
Okay. Yes, thank you. So Prof. Sung Soo is yeah, we will talk about the short heat wave. Yeah,
Yep.
the time is yours, Prof. Sung Soo. Yeah.
Thank you, Elite, my best.
Yes.
Hello, everybody. It's a great honor to have a chance to talk about things I've been working on for the starting from last year. I'm going to talk about the heat waves, which might be very familiar with in terms of disaster for many of you, or maybe a little bit new to somebody who lives in tropical region, because they already feel the very hot temperature, high temperature all year round, and they don't feel like this high temperature as a heat wave. But what I'm going to talk about is not just a regional thing. The things, the impact of a heat wave, such like disaster, newly recognized disaster, such as a heat wave, is not just a meteorological or climatological problem. It can be a social problem. That might be the focus of my talk. Anyway, before I begin, I'm greatly appreciate for everyone who prepared this nice event, especially many of you are already my good friend. I've been to Indonesia a couple of times, especially Jogja, and but background picture of can you see the background picture of yeah, that was a view of shore side of Lombok. I've been there last January. I mean, not this year. Nobody moves this year. So last year, just right before the outbreak of COVID-19, I have visited the Jogja and Lombok for a week with my student to to make collaboration with the peoples over there, and we had a very great time, especially in Lombok. Anyway, let me start my talk. Let me share my screen. Okay. Can you see my screen?
Yeah.
Yes.
Yeah. Is that the screen show mode or the editing mode? It depends.
Yeah, it's full screen.
A full screen. Okay, good. Yeah, I titled my talk as "Surge of Heat Wave" to make a bit the impact, a bit of impact. I'm a professor in Chungbuk National University in South Korea. I mean, especially I work for the Department of Civil Engineering and the Department of Disaster Prevention Engineering. I've been working for the disaster analysis and risk assessment for the meteorological and sometimes the geological event such as a volcanic disaster. Okay. Recently, Korea concerns about heat wave. Actually, this IPCC fifth report predict more than 5-degree increase of ground temperature in the next 80 years. I'm sure I'm not gonna live that long, but for my children and their children, that can be a very serious problem. And we already know that in year 1995 in Chicago, only during just 1 week, nearly 800 people died of this heat wave, and we already knew that tens of thousands casualty happens in all over the Europe in year 2003 due to heat wave. South Korea also has suffered heat wave related victims, especially since last decade, especially since the year 2012. In year 2012, actually before year 2010, we don't have that much of the focus or the attention to the heat-related disease or patient or victims. But in year 2012, we have about 1,000 heat-related patients and 15 deaths. Deaths only counted whenever that death or patient visited the emergency medical center. If they visited like a regular hospital and or sometimes they didn't visit the hospital and just they died because of heat wave. Just we assume that because the clarification about the claim of this heat-related deaths are officially accepted only when the temperature of a dead body is over 40 degrees Celsius. But once people died alone, usually alone their home, and they were found, usually they were found like a couple of hours later, sometimes a week later. And we just assert that the heat waves, the cause of that heat, the random deaths across the Korea, but officially it couldn't be counted as a heat-related victim. So this number, like 15 deaths and 984 patients, is just an official count, and we thought we are thinking that the actual number of victims will be like at least twofold, threefold, sometimes they assume that tenfold. In year 2018 was much serious because we had official deaths of 160 and heat-related patients who visited the emergency medical center is more than 4,500. You can see the increase of heat-related deaths. The red line represented deaths and the black line represented heat wave days all across the Korean Peninsula. Year 2018 is one of the hottest year in Korea, especially Northwestern Pacific. And everybody have been thinking that these heat-related victims occur because of a high temperature, like heat wave days or tropical night, and that's correct. But we have found that this meteorological condition is not the only cause of heat-related victims. According to this well-known research by Klinenberg in year 2002, who extensively studied the cause of the heat-related victims in Chicago in 1995, and he concluded that this heat wave-related victims occurred not just because climatological cause, but also of a social cause. And the rest of the bottom pictures are some of the data related to the heat-related phenomenon in Korea and deaths in Korea. So let's begin with what is a heat wave. Usually, dictionary on the basis of dictionary, heat wave is a period of excessively hot weather, of course, accompanied by high humidity, especially around the oceanic region. A heat wave is usually measured relatively to the usual temperature or usual weather or the normality in that specific region. For example, usually the average temperature during summertime in Korea is a high temperature somewhere around 28 Celsius to 31. But recently, especially after 2010, the highest temperature sometimes reaches more than 40 degrees Celsius, and that they lasted a week. So that can be defined as a heat wave. But if you are living in a tropical region, right there, like Indonesia, the temperature, people from a harder climate sometimes consider that kind of a temperature. For example, 33 degrees Celsius, 35 degrees Celsius, that can be regarded as normal. But this climate change thing differs the distribute all kinds of anomaly, especially temperature-wide, all across the globe, and that can happen anywhere. In Korea, if this heat wave is expected, usually government issues some sort of the watch and warning. For example, if the maximum daily temperature expected as 33 degrees Celsius and higher for more than 2 days, they issue the heat wave watch. But if the temperature increases more, like 35 degrees Celsius or higher, they issue a heat wave warning. And they also issue a tropical night warning. For example, if the minimum temperature, daily temperature expected as 25 degrees Celsius or higher, they issue a tropical night. And starting from the year before last year, the Korean government issues this heat wave watch and warning and tropical night, not just based on this dry temperature. They issues this watch and warning based on heat index, based on dry temperature and the humidity. People talk about the disaster and victim and actual the losses in Korea due to heat wave. I'm gonna briefly introduce the research which I am leading for the heat wave disaster in Korea. The objective of the research I'm currently doing is identification of socio-environmental cause of heat wave victims. Because there are so many studies regarding heat wave and the meteorological cause, and the geophysical study has been extensively carried out for the last decades in Korea, especially in Korea. But this is the first attempt to identify the socio and the environmental cause of heat wave victims in Korea. This research started last year and it will be lasted for 5 years until year 2004. And it is funded by the Korean government, the Ministry of Interior and Safety. What this research pursues is that to develop any kind of a social autopsy process. You may be heard of this social autopsy, comparing to the medical autopsy on the right side of this screen. We usually, when we talk about autopsy, it is done by usually doctors or medical investigators to identify direct cause of incident. For example, for the heat wave related deaths, this medical autopsy identify why the victim really died of. So he identified whether this heart failure or temperature increase or the intestine failure. That's what the medical point of view is the focus of this medical autopsy. But this social autopsy is different. On the left side of the screen, I'm sorry about some of the Korean characters, but it is about the social tragic, the news report about the social tragic incident. For example, about 2 years back, the one family with four, like a father and mother and 2 children, commit suicide and found out that they are not that economically hard. I mean, they lived in somewhere in Seoul. Probably you heard of the housing prices. Seoul is as high as like Tokyo. So that means that they have enough of economical capacity and the social capacity to live on, but they made the family suicide and found out that they are suffered from relative poorness. They think they are poor because their friends are richer than them. And the social happening is like a maternal fatality. The cause of this kind of a social happening, the social tragedy, the people try to use this social autopsy to understand what really happened and what was the real cause of this tragic incident. And this research is trying to develop this social autopsy process to understand direct and indirect cause of these heat-related victims. To pursue and to achieve that purpose, we approach this heat-related victim and the phenomena using this multi-layered investigation. The first layer is about the regional and societal ecology. So we take a look at that victim and their friends, their family, and where they live, and how they eat, where they visit, that sort of thing, and then whom they met. And the second layer is about the right outside of this first layer is a role of public service. That means what this society, community, and even nation have done for the heat-related victim before they die or before they suffered from the disease. The main focus is the equality and the activeness and adaptability of this public service. The last layer is about the role of media. Sometimes the media acts very helpful role in disastrous environmental and disastrous period, but sometimes due to this commercialism, this media distort the actual fact or actual truth or actual happening, especially related to these victims. So this is the three layer we are currently doing for the study of this heat-related victims and the cause of their incident. Let me talk about what happened in terms of heat wave in South Korea for the last couple of years. This is the heat wave day, the count of heat wave days and the tropical nights from year 2016 to year 2019. Especially, you can see the year 2018, all of the Korea, at least more than a month of heat wave day has been prevailing. It started from June to end of August or sometimes in the middle of September for during like 100 days. For example, a southern part of South Korea, the heat wave days lasted more than like 42 days. That means out of 100 days, the more than 40% of day has been declared as a heat wave watch or a heat wave warning. Also, the tropical night has been more than like, especially southern island in Korea, more than 40 days of tropical nights. I'm not sure if you visited Korea. Korea is notorious about the very humid condition during summertime. With the temperature more than 35 or 36, the relative humidity exceeds sometimes 80%. That means you are just in the middle of like water, and there's no evaporation because of high humidity and high temperature. It is very horrendous. Anyway, year 2018 was notorious, and many people suffered even though they didn't go to the emergency room, or they didn't suffer the apparent and any kind of heat-related symptoms, but many people suffered from heat-related phenomena over the like 3 months in 2018. Let me first talk about the heat-related patient. There are about 4,526 patients visited the emergency room, but according to other sources like the medical insurance record, it was found that more than 35,000 people visited not just the emergency room, but also like a local hospital because of heat-related symptoms. Anyway, starting from May to September until the end of September, Korean Center for Disease Control, the correspond like a equivalent to the CDC in America, they operate the heat wave watches. That means there are about 500 emergency medical centers all over Korea, and by law, whenever there is a people and the symptom shows a heat-related phenomenon, that emergency medical center must report that condition of the people to the KCDC on a daily basis. Based on the data, we found that year 2018, more than 4,500 patients visited the emergency room and about 1% deaths. First, to talk about the patient, it was found out that we can prostate that about 30% of patients are 65 years old or older. 1/3 of patients are the elderly. And regionally, there are some Korean characters about the Korean representative Korean metropolitan area, and the high region is the southern part of Korea, because southern Korea is from north to south. It is about 700 kilometers in Korea, even though it is not that far, but there are big differences in temperature-wise from northern part of the Korean Peninsula and the southern part of the Korean Peninsula. And the gender-wise, the patient, about 3/4 of patients are male, and 1/4 female, about 74% of patients. That means more than 3,300 patients are male and the rest are female. And the symptoms, half of the heat wave patient shows heat exhaustion, and followed by heat stroke, and the third cause of the symptoms are heat cramp. And occupation-wise, there are a bunch of different occupations, so we call it etc. It is about 1/3, and about 1/5 doesn't have any job because some of them, many of them are elderly, especially older than 70. And as far as occupation-wise, the craftsman is about 1/10, which means about 500 patients are craftsmen working indoor or outdoor. Let's talk about the time of incident and the place of incident. The most of the heat wave patients visited the emergency room during daytime. Half of them starting from noon to 5 o'clock in the afternoon. And the place of incident is that outdoor place is the majority, like 28%, and indoor, especially in house, is about 14%. Outdoor roadside is about 13%. As far as the indoor is concerned, half of them, half of patients were in house, and about 23% in workplaces. For the outdoor, the patient workplace is 38%, and roadside is about 80%, and the farm field is about 15%. Even though the officially declared heat-related death is 48, only 48, but the statistical data shows about 200. Anyway, about 70% of heat-related deaths are for 65 years old. In the previous slide, about 1/3 of heat-related patients are 65 years and old, but as far as the deaths are concerned, 70% of death comes from 65 years old or older. And the gender-wise, the male and female differ not that much. As far as the patient is concerned, male patients are dominated for the number of patients, but the casualty-wise, the death-wise, the deaths of male are nearly equivalent to the deaths of female, and the cause of the heat wave death 100% comes from heat stroke. This heat-related disease usually start from sometimes the heat cramp or heat the exhaustion. But if that heat-related patient who shows symptoms such as cramp or exhaustion were properly and promptly treated in time, that symptom developed into the heat stroke and the leading result in being dead. So that's a very serious symptoms. Also, the heat-related deaths occurred half of time in daytime, and compared to the about 1/3 of patients are from outdoor, but nearly 2/3 of deaths occurred outdoors, such as roadside or farm field. These 12 counts of deaths comes from the farm field during daytime. In order to, this is just statistical data. In order to investigate cause of the heat wave disaster, we take a look at more detailedly the social, environmental, geosocial data. This is some of the statistical and the geostatistical data related to heat wave victims, especially in Busan. This is the Korean Peninsula. This is where Seoul is, and this is where Busan is. It is about 500 kilometers south of Seoul. This is the heat-related victim, the distribution of heat-related victims, where red are the heat-related victims are higher, such as western part of this Busan, the city of Busan. More than 60 victims occurred during year 2018, compared to the nearly 0 patient in the eastern part of the Busan city. For your information, this Busan is alongside the shoreline, so this southeastern part of this city of Busan is where the Korean Strait is, between Korean Peninsula and Japan. First, we try to investigate how the land is used. This picture shows the land cover map. For example, this dark green area displays where tall vegetations are, like a forest, and the red area represents the urban area. And this is the maximum temperature for different land cover and the minimum temperature for different land cover for the August 1st, the specific one day, August 1st, year 2018. For your information, out of these 208 heat wave victims in city of Busan in year 2018, on this just one day, about 72 heat wave patients visited the emergency medical center all across Busan. When you see this one, the forest area is the lowest shows the lowest temperature as we expected. And you remember the most of the heat wave deaths occurs farm field, which is this the green and bare area, such as this one. This greenish color represents grass and bare area, and this bluish color represents agricultural area, which shows a very high temperature, which means people suffer heat wave related disease or some even deaths when many people walking in the field during the high temperature of the daytime.
Excuse me, Pak Sung. Probably we have almost limited time. Probably
Okay,
I only give you 1 or 2 minutes, please.
Okay,
Thank you.
sure, I will do that. Thank you.
Thank you.
Yeah. This is some of the geostatistical data, especially for the age-wise. Let me skip to this aging index. Aging index is the elderly people divided by the younger people, and then we show that some of the regions have a very high aging index, which also represent the interpreted as a very vulnerable to heat wave. The related victims and the vulnerability. Let me go to directly the next topic. In our study, we are focused on the heat wave prone class because these heat related disaster victims are not equally happening to the all geographically or economically, and we found out that some class, for example, economically, socially, there are the heat wave prone class, especially elderly living alone and sometimes outdoor workers. They are very prone to heat, very vulnerable to heat wave. And we had this quantitative study by survey for a psychological feature for the outdoor workers. For the more than 500 outdoor workers, we have found very interesting results that if somebody has a characteristics of high responsibility for anything around him or her, he or
saya lihat ada Burina punya ini saya
he or she is very vulnerable to heat wave. And another socio-economic environmental factor we need to focus on is asymmetry of heat wave disaster. For example, elderly living alone, they are very vulnerable to the heat wave, and because sometimes they have to survive even though the heat wave prevailed all the Korean peninsula, such as like this one. These are some of the structural mitigation measures which we are considered to mitigate the heat-related thing. Some of them are wind forest, clean load, cooling fog, and roof vegetation. These are just the structural mitigation, but these cannot touch the heat wave prone class, especially elderly people, living alone people, and the outdoor workers who have to work in spite of heat wave. So we need to focus on these social environmental cause and try to develop that sort of indirect mitigation measure, and we are trying to develop that one. Thank you. I think this is the most of the things I need to I would like to talk today. And terima kasih. Thank you.
Thank you so much. Allow me to call you Pak Sungsu, yeah, because I mean, like, actually, it's okay just call Sungsu, but for me, it's not really.
Okay.
Just call Pak Sungsu. It's easy one. Okay. Thank you so much, Pak Sungsu. It's really interesting, actually, but because of we have limited time, so I have to reminding you. But it's okay. Actually, Pak Sungsung talk about the heat wave, even though it's still really rare in Indonesia. But based on the situation, we can learn from coronavirus. It is impossible, but it's happened and then come to Indonesia. So I think it's really, really important for us to learn from the lesson learning from the Korea. I mean, like, it's really important because, I mean, like, it's the uncertainty of climate change will be impact on the human surviving. Yeah, I mean, like, related to our sustainability, not only the environmental but the human. It's really interesting. But excuse me, Pak Sungsung, before we continue to question and ask, I think I will continue to the next presentation. Pak Jun Pulin, because we learn from the lesson. If I directly give the time, probably the audience will be not ask anything. So just give them time until they thinking what they will ask. So after after Dr. Prof. John Pulin, we will give time for both of you to answer the question.
Okay.
Okay.
Thank you.
Yeah, thank you, Pak Sungso.
Okay.
Yeah, well, thank you, all the participants. Even though already midday, we still have continue because I think you still keep doing other activity while we are watching the presentation. Okay, the last guest from our neighbors, Prof. John Pulin. Hi, Prof. John Pulin. Pak John, what I call you, Pak John? Pak Pulin.
Yes,
Sorry,
yes,
Prof.
you can call me Pak Jan. Yeah.
Pak John. Okay, nice.
Yeah.
Yeah, because you are a Filipino, some similarity languages between Indonesian and Filipino, probably. Yeah. Okay, Pak John. Pak John is a professor from Forestry and Natural Resources from the University of Filipino Lebanos, and then he do as a professor visiting of Tokyo University. And then the background, I mean, like Pak Jun got the PhD from NU, yeah, from Australia. Okay, now Pak Jun, it's the same time. I will give time for you around 15 minutes to talk about the presentation for the audience. Okay, the platform is yours, Pak Jun. Thank you.
Thank you so much, and good morning from my good afternoon already from my end. The title of my presentation is Climate Change, Disaster Risk, and Human Security, Asia's Challenges and Way Forward. This is based on a recent book published by Springer, which a number of us have edited. So I have divided my talk into 5 major parts, and I won't bore you with the details of introducing each part in the interest of time. So let me start with understanding more the linkages of the key terms climate change, disaster risk, and human security. Of course, as very well articulated already by our previous speakers, indeed, there is this strong linkage between weather and climate events such as typhoons, floods, drought, and even, as mentioned also earlier by the previous speakers, heat waves, as well as natural occurrences. And in fact, this can turn into disaster due to vulnerable conditions and exposure. And we know that Philippines, Indonesia, and many other parts of Asia are actually both exposed, but also have relatively high vulnerability. Now, in my talk, I explore the relationship of climate change on the one hand, as you can see on this particular figure, the observed and projected impacts ranging from biological system to human and managed system in terms of, and it's in interaction on the other hand with natural disasters. So this is where climate change and disaster risk essentially interfaces, which include, of course, factors like biological hazards, even geophysical in the context of natural disasters. And of course, an interaction of that, or intersection rather, is the hydrometeorological disasters that is of course associated with climate change. And that we are saying here that this interaction has actually undermined, based on the literature, but also on the basis of a number of researches and our own experience, this undermine human security, which in turn can of course, influence the resilience and the future of Asia. So I'm drawing from the work that we did at IPCC, where I had an opportunity to be part of the coordinating lead authors on the chapter on human security at AR5, where we define human security as a condition that exists essentially when vital core of human lives is protected and when the people have freedom and capacity to live with dignity. What we mean by core of vital core of human lives include universal and culturally specific material and non-material elements which are necessary for people to act on their interests. Of course, we understand also that human insecurity, on the other hand, is almost never does not have a single cause, but instead it emerges from the interaction of multiple factors ranging from climate, technology, science, economics, finance, policy, and so on. Now, let's have a quick look at the situation of Asia. Of course, we know that Asia has experienced more disasters than any other continent in the world. And we are drawing from essentially a database which provide a very interesting historical trend ranging from 1900 to 2019. And as indicated in this particular database, 6,213 out of the more than 15,000 total world disaster actually within this particular period occurred in Asia. There is also an abrupt increase in the annual disaster occurrences in Asia as observed towards the end of the century, with all of the hazards increasing very significantly. And of course, as you can see in the same and this particular figure, storm, flood, extreme temperature, and even drought, essentially, which is what we call as hydrometeorological disasters, are actually induced by this type of disasters, which is climate related. If we look at the performance of the climate risk index based on the recent German watch, it says here that 6 out of the top countries in climate index rankings are Asian countries, including, among others, Myanmar, Philippines, Pakistan, Vietnam, Bangladesh, Thailand, and even Nepal. Of course, Asia also tallied the most number of disaster deaths, again, drawing from the same database. So more than 25 million out of the 32 million, which constitute 80% of the total world fatalities in terms of disaster actually occurred in Asia. Drought together with even flooding have caused the most number of fatalities since 1900, numbering to as much as 9.5 million in terms of drought and 6.8 million in terms of flood and so on. In Asia, of course, China, being a very big country, also has recorded the highest number of disaster deaths within the same period with a number of around 12.5 to 1 million within the same period. Of course, India followed very closely, Bangladesh, Indonesia also actually ranked 4th, and then Japan, Pakistan, and also among the top 10 is my own country, which is Philippines. There is also a need to look into socioeconomic conditions through human security indicators to determine its contribution to Asia's vulnerability as a region. Of course, we look at economic security in terms of poverty, food security, including undernourishment, health security in terms of basic water resources, environmental security, even personal security in terms of displacement due to disasters, and community security in terms of displacement due to conflict or violence. And again, the UN Global SDG database, World Development Indicators, clearly stipulated that some of socioeconomic indicators in Asia lag behind that of the world statistics, meaning to say that the percent share of Asia's population in terms of these human security categories exceeded that of the percent share or the average, the percent share of the world population or the average. So this includes, among others, food security, where the percent share of Asia's population is 11.14%, as against the average of the world, which is 10.80%. The same holds true for environmental security, particularly PM 2.5 air pollution, as well as the population exposed to levels exceeding the WHO guideline value. So this is 93.47% for Asia in terms of percent share of population, as against 91.3% of the percent share of the world population. Personal security in terms of internally displaced persons, new displacement associated with disasters is also a little bit higher than the world average, as well as community security. So what we are saying here is that the combination of the frequency of natural occurrence and relatively poor socioeconomic condition figures in various human security aspects makes Asia more vulnerable to climate change and disaster risks. Of course, what contributed to the increase in disaster, as we have seen very prominently in the previous graph that I have presented, as indicated by Siniberant et al. In 2012, climate change can in fact enhance the frequency, intensity, even the spatial extent, the duration and timing of weather and climate extremes that can further result to unprecedented extremes, and therefore undermining the human security of Asia. Of course, as elaborated by the previous presenters, there is the dramatic rise of carbon dioxide in the atmosphere that contributed to the greenhouse gas concentration worldwide, and our world in data attested to this. And of course, the trends of carbon emission, both in Asia and in the world, exhibit the said rise that was attributed to global warming. Of course, we have also the annual land surface anomaly from 1910 to 2018 as a direct manifestation of the global warming based on the NOAA data that we also put together, as well as the positive anomaly that a significant increase in temperature has been recorded. And of course, even the recent working group one of the IPCC 6 assessment report showed very strongly this particular behavior. We're saying that improvements to achieve human security in Asia are actually occurring despite persistent threats to climate change and disaster risk to human security, and has been made possible to a certain extent by international collaborations and assistance, multi-stakeholder partnerships, and mainstreaming climate change adaptation and disaster risk management strategies.
Excuse me, Pak John. Excuse me, Pak John. Yeah, probably we have only like 2 minutes more.
Yes, yes.
Okay,
So,
thank
for
you.
instance, Asia alone receives a big portion of humanitarian aid compared to other regions. And then the future outlook is this, and this is based on 2018 IPCC special report, where increasing anthropogenic emissions, including greenhouse gas, aerosols, and their precursors, will have triggered natural climate variability. And of course, these are the different projected climate change impacts in agriculture, health, economy, water, and even marine ecosystems. So what are our ways forward? First, take the lead and pursue climate resilient and sustainable development pathways. Second is to prioritize advancement in science and technology for better implementation of climate change and DRR. And again, our previous speakers have alluded very well to this. Third is build on a scientific capacity from regional to local level. Fourth is increase investment in ICT for effective communication. Fifth one is better management of humanitarian assistance, improve governance at national and even local level, integrate scientific and local knowledge as a tool for decision making, and incorporate climate change and disaster management in educational curricula. So my last slide is a take-home message. We argue that the geographic position and the topography of Asia are enough reasons to put the region in peril. And these are further exacerbated by relatively poor adaptive capacity due to socioeconomic conditions of the developing states in the region. Projections of worsening climate change and disaster risk impacts place the region in a crossroads towards secure and resilient Asia. However, some climate change actions and disaster risk management strategies are actually applicable across countries, but it is likely that modifications are necessary to match the local context and needs to achieve a climate resilient and human secured region. So thank you very much. And for more information, we have this recent book published by Springer Nature entitled Climate Change, Disaster Risk, and Human Security, if you are more interested about my talk. Thank you so much.
Yes, thank you so much, Pak Juan and Pak Sungsu, for the presentation. Actually, really interesting, but the time that's limited us to dig more and more. But I think we can contact, because there is a number in the presentation, and then we can continue to learn more from Pak Juan and Pak Sungsu. Okay, ladies and gentlemen, probably we already have to really amazing presentation, and then I will give the time for you guys if you want to ask probably one question for each presenter. Anyone for present? So many very interesting, yeah. Yeah, anyone?
Excuse me, Miss. I would like to ask Professor Sangsu if possible.
Yeah.
Okay, yeah. From can you introduce your name? Yeah, and then ask the question, please. Okay, one for Mr. Sungsu, and then another please prepare for Pak Juan, please. Okay.
Okay. 안녕하십니까? 제 이름은 기라입니다.
안녕하세요.
That's all the Korean I know, sir. Okay, I have two questions. The first one is related to the heat-related disaster that you talked about before. My question is that, is the increase of that heat wave critical for from your point of view? Because is it out of pattern as temperature-wise and also time-wise? Because you said that before it's about 28 to 31 Celsius, and nowadays
probably one question, only one question, Meta, yeah, Meta, only one question, yeah. Okay, only one, yeah.
Okay, so is it really critical? Because as we know that in the UN General Assembly, Antonio Guterres said that the situations for the climate change is critical. Even the Paris Agreement may not be relevant anymore.
Mhm.
And then actually I wanted to ask about the decisions of the President Moon Jae-in to include
Excuse
BTS.
me, I mean, like, yeah, probably you can chat down in the chat because we only give limited one question
Okay,
per person.
thank
Yeah,
you.
you can chat and
But I
then
hope
next
you can answer that.
Sung will be answer. Yeah. Okay.
Okay.
Sorry, Meta. Yeah.
Okay, my answer will be K. Because Korean people get very used to that sort of temperature region between somewhere around 30 degrees Celsius for their whole life. But for the last decades, the temperature gradually, but not really gradually, increased to 33, sometimes 35 degree, and the people have difficulty to adjust that one. But that's the one cause of heat-related the disease or even death. And I think the first cause is a high temperature. But what I'm trying to say is that that is not the only reason for heat wave-like disaster. There's another big reason coming from social and economical environmental background. Okay, thank you.
Thank you so much, Pak Sung Sung. Yeah.
Yep.
Later, the Meta, can you write down another question in the
Okay.
chat and then
Just
yeah.
give me the chat.
I'll give you the chat directly. Yeah, with
Sure.
Korean language. Yeah.
Okay, great.
Okay. The next probably any question for Pak John. Okay, if still not have a question, probably Pak John, they will be write down in the chat. They're still thinking how to write down in Filipino. Because the previous question asked in Korea, now they want to compete and have to write down in Filipino. Yeah. Okay, ladies and gentlemen, for this expert keynote speaker, it's really interesting. For the last two, talk about the climate change, natural disaster, and human security. It's a one circle that's there is some sets say if there is the beautiful view, beautiful geography, beautiful landscape, it will be a lot of disaster. So I mean, like we stay in the really beautiful landscape. It's mean we will have more face a lot of disaster. So to reduce, we have to collaborate each other to reduce the disaster and then to protect the human security. Okay, as a part of appreciation us for both really expert speaker, we want to give them both of our standing speakers certificate. Similarly before, please you open your mood and then we can give applause so we still can wake up and then still continue this conference. Okay, the first one for Professor Dr. Sungli. Please give applause. Yeah, thank you so much, Pak Sung Sung. And the next one for Pak Prof. John Pulin. Yeah,
Thank you.
Thank you.
Thank you so much. Thank you.
Thank you so much, Pak Prof. John Pulin.
Thank you. Thank you.
Yeah. Okay, ladies and gentlemen, that's all our session from the expert speaker. Now the time I give it back to the host, Miss Rina. Thank you, Miss Rina.
Thank you very much, the moderator and also the expert speakers for the remarkable discussion. I hope we all still have spirit to following this conference. So ladies and gentlemen, let's continue to the next agenda. The next agenda is presentation by invited speaker. Please be joining with us. Dr. Nelly Riama from Badan Meteorologi, Klimatologi, dan Geofisika, Dr. Andreas Dipi Patria from Kementerian Koordinator Bidang Kemaritiman dan Investasi, Dr. Rahmawati Hussein from Muhammadiyah Disaster Management Center. This presentation and discussion will be moderated by Dr. Dani Saraswati. To Mrs. Dani Saraswati, time is yours.
Thank you, Mrs. Rina. Good afternoon, distinguished ladies and gentlemen. Thank you so much for still joining this session. I'm Dani Saraswati from the University of Papua. I will moderating this session. In this session, there will be 3 honorable invited speakers. In this session, the first speaker is Dr. Nelly Floridariama, and the second speaker is Dr. Andreas Pigi Patria, and the third speaker is Dr. Rahmawati Hussein. Ladies and gentlemen, in this session, after 3 presentations from all invited speakers, it will be continued by discussion and certificate submission. Each invited speaker will be given 15 minutes talk, while QA will be 15 minutes. Ladies and gentlemen, I would like to introduce Ibu Dr. Nelly Floridariama. Dr. Nelly Floridariama is currently the Director of Center for Research and Development at Indonesian Agency for Meteorology, Climatology, and Geophysics. She is responsible for coordinating and conducting research, development, and engineering in the field of meteorology, climatology, and geophysics. In recent years, she has been working on several national and international research activities, including in marine meteorology and oceanography. One of her accomplishments is to develop the Indonesian coastal inundation forecasting system by the assistance of WMO. From 2017 to 2020, she had been appointed to be the Vice Chair of GCOMM expert team on disaster risk reduction. Dr. Nelly will presenting the recent development of early warning system for hydrometeorological disaster in Indonesia. Dr. Nelly, the time is yours.
Yeah, thank you, Ibu Dani. I would like to share my screen. Okay. I think, sorry, I need to go to the first slide. Yeah, thank you very much for the opportunity for me, especially for Pak Henry. It took me maybe several months ago. Yeah, the title of my presentation is the recent development of early warning system of hydrometeorological disaster in Indonesia. So, as you may aware, that I work for the Indonesian Agency for Meteorology, Climatology, and Geophysics. In Indonesia, we must aware that how our weather and climate very challenging in terms of to make a forecasting and prediction, because we are in the middle of two large ocean and 2 continents, and this scheme show you what events that take place in our region, and this is it is very related with our geographical location. So for our weather and climate phenomena, we also consider about the El Nino and La Nina, and also on the monsoon activity, and for of course because more almost 70% of our region consists of waters, we also need to consider the behavior of the sea surface temperature, the condition of the Indian Ocean, and the monsoon, as I have mentioned before, and the MCO, the Mediterranean oscillation. On the other hand, we also notice that how our natural disaster, this is the statistic of natural disaster in Indonesia, and we notice that the natural disaster related to weather and climate is around 69%. But we can also give you information about the the situation in Indonesia, if we want to have a planning from January to December, we know what kind of hydrometeorological disaster that take place from because we just only have 2 seasons, wet season and dry season, but in between we have the transition period. So we can identify what kind of hydrological disaster that happen right now. We also can show you how the increasing of the CO2 concentration measured in one of our station in Indonesia in Bukit Tinggi, Batu Tawang. Although it's less than global average concentration, but it shows the increasing trend of the CO2 concentration. And you can also show you the increasing trend of temperature in Indonesia, although it's still less from the global temperature trend. You can also, this is for Jakarta because we have still special research on this, and we can also show you how the increasing temperature also happen in Jakarta during 130 years. And maybe you already notice right now when we talk about the rainfall, we experience that we have more intensity of rainfall and more severe. So if we compare to what we have in, let's say, 20 years ago, the amount maybe it's the same, but the intensity will become more and more higher and severe. And because we talk here and invited by University of Papua, so I want to show you also how the climate change affect the glaciers in Puncak Jaya. So this is the paper that just published 2 years ago about the disappearance of the last tropical glacier in our country. And it can show you that now we have a very decreasing of the coverage of the glacier in Puncak Jaya. And 3 or 4 years ago, BMKV visited Puncak Jaya and make the measurement in the field. This is the picture measurement. And because of that, BMKG, as you know, that we must provide information on weather, climate, and geophysics. So we need to always improve our accuracy because the challenging situation now. So we develop what we call the Indonesian numerical weather prediction. As I have mentioned already, that the situation in Indonesia is very challenging in terms of provision of the information of weather, climate, and geophysics, and all the researchers in Indonesia and also international researchers realized that the region with the largest area of precipitation on Earth is in the American continent, and Indonesia is the major part of this continent. So this precipitation will known as and reflect as atmospheric divergence to the global level. So we do believe that maritime continental precipitation is a key variable to predict correctly for global weather and climate. And we also noticed that this precipitation has very large error in climate models because the geographical situation and because of the observation especially in the ocean part is actually small amount. So because of that, we want to improve our ability to provide more accurate information. We conduct intensive research to run our numerical weather prediction, and we do hope that we got this kind of prediction, we will get more accurate information because on this model, we estimate the data from our region to the model. So we also want to keep our independence in the production of weather and climate information in the region. So this is the status of our model right now. We are on the version 1.0. We have already done scaling 9 kilometers for Indonesia area and 2 kilometers for Java. And we have estimated data from our observation, our automatic weather system, our revision, and our radar data. So this is the structure and the project of our model. And we also have some collaboration with KMA, Korean Meteorological Administration, and they provide us with the story from our collaboration. So this is the result of our model. So we can see that we can make the first one is the 9 kilometer resolution for all Indonesian area, and we also have the second is the 3 kilometer in Java Island, and we can also show you the position or the location of the observation that disseminate in this model. And we can we also develop give the meteogram, and we can have a prediction of 3 days ahead, and the amount of rainfall and the cover, and also the temperature, and also the wind, the same. So as the result of our development, we apply this model to the latest tropical cyclone that happened in our country. In April, we have this Seroja tropical cyclone. So we know that how the destruction of the Seroja, especially in Nusa Tenggara Timur, is Nusa Tenggara, and in BNKG we already give a warning for this tropical cyclone from the 2nd of April, and we know that it's give some impact on the 4th of April. This is the radar data during the cyclone, and this is how the cyclone from our country of South Sea, and then move forward to to Australia. And this is also the extreme rainfall that happened during the cyclone. And what I want to show to you that how our model can show the cyclone.
Dr. Nelly? Dr. Nelly, I'm so sorry. You
How
have
many minutes?
2 minutes left for your presentation. Can you just shift to the summary of your talk?
Yeah, this is the result of our model. And this is also the track of the typical cyclone. And finally, I can conclude my presentation that as an articulated country, the complex land, sea distribution, and capability of the prediction of high impact events in Indonesia is extremely challenging. So with this development of the Indonesian numerical weather prediction, we do hope that we can provide more accurate weather information, especially for extreme events. That's all my presentation. Thank you very much. Terima kasih.
Thank you very much, Dr. Nelly, for sharing the very valuable and informative talks. I would briefly note that the lesson of your talk that based on the weather and climate phenomenon with increasing trend of atmospheric composition, for example, CO2, increasing temperature, extreme rainfall, BMKG needs to conduct intensive research and develop early warning system by creating independent production of weather and climate information. And Indonesia has been developed it to provide more accurate weather information, especially for the extreme events. Once again, thank you very much, Dr. Nelly, for the excellent talks. Now we invite the next speaker, Dr. Andreas Pipi Patria, the Coordinating Ministry of Maritime and Investment. Dr. Patria has a lot of experiences and awards, but I only list few of it. He is an expert council of the Fisheries Undergraduate Association, and then member of Indonesian Marine and Fisheries Social Economic Research Network, member of the Indonesian Dynamic System Association, Indonesia Aquaculture Community Center Management Board. Dr. Patria, it's a great honor to have you here. At this time, Dr. Patria will presenting strategies for mitigation and adaptation to climate change impacts on coastal area and small islands in Indonesia. And the time is yours, Dr. Patria.
Thank you, Bu Dani. Good afternoon, distinguished guests, ladies and gentlemen, on this virtual event. It gives me a great pleasure to be with you all on the occasion of University Forum for Disaster Risk Reduction. By the way, as the coordinating ministry, actually, we cannot talk about a technical aspect regarding risk reduction, but our task is more to direct and coordinate various problems encountered in implementing existing policies, including policies for disaster management. So let me share my presentation. I have problem to my presentation. Maybe the organizer can help me to share my presentation.
Ivan, help Mr. Andreas. Please, Ivan.
Okay.
Yeah, I can find my presentation in. Okay, can you see my presentation?
Yeah, please continue.
Okay. Okay, on this occasion, I will share about the strategies for mitigation and adaptation to climate change impact on coastal and small island in Indonesia. Okay, Indonesia, as we know, is the world largest island country located in Southeast Asia, nested between the Indian Ocean and Pacific Ocean. Our country comprises more than about 13,000 verified islands out of a total of 70,000, and thus extend over an area of about 2 million square kilometers. Given its location on the equator, the climate is dominated by tropical condition with two distinct monsoonal and dry season. In terms of geography, the country comprises various ecoregions from lowland to mountainous area running through the major island in the west or coast of Sumatra, in the west Java, Kalimantan, Sulawesi, or Papua, which also receive the highest annual rainfall. Indonesia is surrounded by an active fault, as we know, with the ring of fire, so it has a high potential for the earthquakes and tsunamis. In addition, Indonesia is also vulnerable to hydro-oceanographic disasters such as abrasion and coastal flooding. Intensity of disaster is increasing and becoming more complex, so must use multi-sectoral and multidisciplinary approach in integrated and coordinated manner. We have to emphasize the need for disaster management system. Naturally, flooding would also be worsened in coastal city and town that more exposed to rising sea levels. However, while the impact have a high spatial variability, affecting the urban and rural areas differently, they also occur as a complex interconnected process. We can see in this picture, when combined, all of this cascading impact could result in massive scale degradation of habitable space in both of natural and environmental. In the next slide, we can see Indonesia faces many natural threats including earthquakes, tsunami, volcanic eruption, flooding, and drought. Based on historical event and risk analysis, Indonesia is highly exposed to tsunamis. The most notable disaster to affect the country was 2004 Indian Ocean earthquakes and tsunami, which affected over 500,000 people and left about 160 Indonesian dead. From 1992 to 2012, there were many tsunamis events throughout Indonesia, caused by earthquakes from the lowest level to the highest level. Indonesia has experienced several major tsunamis, and almost 90% of them were caused by earthquakes at sea, and 9% caused by volcanic eruption, and 1% due to underwater landslide. During this period, approximately 172 tsunamis have occurred in Indonesia. From that time, it was not that more than 40% of tsunami events occurred in eastern Indonesia, where the epicenter of earthquake was in the Moluccas Sea area. This is the tsunami-prone area in Indonesia. As a country with a vast coastal area, Indonesia obligated to oversee its coastal area, especially for the small islands. The coastal region has a strategic value that plays an important role in improving the national economy and people welfare. However, coastal areas are highly vulnerable to the threats of damage. Climate change affects every corner of our planet, from the poles to the tropic and from the mountain to the ocean. People and nature worldwide are already feeling the effects, like water supplies are shrinking, extreme weather even increasing in frequency and intensity, beach erosion, flooding, seawater intrusion, sediment deposit change in the coastal area. Climate change may have significant exacerbating effect to the impact of hydrometeorological hazard, given following change in regional precipitation and temperature. Under a high emission scenario, the mean annual temperature could increase by about 3.8 degrees Celsius on average between 1990 and 2100. An estimated of 4 million people could be affected by worsened flooding in the coastal region following sea level rise. Sea level rise is projected to occur at the rate of 5 millimeter per year, and 1 meter rise could affect 39% of the country GDPs, which are largely generated at the coastal region. Conversely, droughts are becoming more severe and are now reported every 3 years during the dry season, mostly in the southern island of Java, Bali, and Nusa Tenggara. Risk involves exposure to hazard, vulnerability, as well as lack of coping capacity is important factor in disaster risk management. This figure shows INFORM's risk profile for Indonesia. INFORM is a global, objective, and transparent tool for understanding the risk of humanitarian crisis. INFORM is a composite indicator developed by the Joint Research Center, combining about 53 indicators into 3 dimensions of risk, like hazard and exposure to them, vulnerability, and the lack of coping capacity. It is a collaboration of the Interagency Standing Committee Reference Group on Risk, Early Warning and Preparedness, and the European Commission. The index results are published once every year. Indonesia has, in 2018, natural hazard and exposure risk of 7.3, and vulnerability score of 2.5, and lack of coping capacity have score of 4.8 from a scale of 10 scale. Physical exposure to tsunamis have a value 9.6, and earthquakes have 8.4. That's 2 indicator is the highest. The number of disaster events caused by geological factor is not too significant compared to the number of disaster caused by hydrometeorological factors. Nevertheless, the geological disaster, especially earthquake and tsunami, in fact, have caused quite a large impact both in terms of victim and economic losses. Tsunami is one of disaster threat for many coastal areas in Indonesia. This disaster is generally triggered by an earthquake at sea, which causes a vertical shift in the seabed. Based on historical records, the tsunami is not a new disaster in Indonesia. In the next slide, the influence of climate change also contribute to the increase in the incident of a hydrometeorological disaster. With a large frequency of event, this disaster group also has a very large impact, especially on the economic and environmental sectors. Both of the direct impact of disaster event and the indirect impact. Human activities also contribute to worsening environmental conditions, such as forest encroachment and for plantation settlement or development activities that affect ecosystem and ecology in buffer zone. In the next slide, we can see the policy and program in Indonesia. Currently, the Race to Zero and Race to Resilience global campaign is well underway as a part of realizing the promise of the Paris Agreement to limit the rise of global warming and achieve a healthy, resilient, and zero of carbon future. The goal of the campaign is by 2030 to catalyze action by every sector to deliver concrete sectoral change needed to fight a global climate change. In dealing with various risks of disaster management, the President of Indonesia has issued instruction to all parties related to disaster management. This is the beginning of the seriousness of commitment of the Indonesian government in dealing with disaster risk. Indonesia National Development Plan Agency, as we know with Bappenas, has recently launched a policy recommendation document that we know the title is Kebijakan Pembangunan Berketahanan Iklim or Climate Resilient Development Policy on April 2021. It will act as a guideline for handling climate change for local and regional government, as well as related institutions to implement the medium-term National Development Plan 2020 and 2024. This will also affect achievement of a goal 13 of the Sustainable Development Goal or SDG. In the medium-term National Development Plan 2020-2024, increasing climate resilience is targeted to reduce potential economic loss from the impact of climate change by 1.1% of GDP by 2024. Climate resilience development policies are an implementation of the Sustainable Development Goals, a low carbon and climate resilience strategy, including a Sendai framework and fulfillment of Paris Agreement targets. And the legal framework for disaster management in Indonesia begin with the enactment of the Law on Disaster Management, a law on the management of the coastal and small island, as well as a maritime law. Disaster Management Law number 24, 2007 also serve the purpose to ensure the implementation of planned, coordinated, and inclusive disaster management, taking into account aspect for local wisdom, building public-private partnership, enhancement of spirit for mutual solidarity and charity, and as well as creating peace, community life, nationhood, and statehood. Government Regulation number 64, 2010, prioritize strengthening the role.
Sorry, Dr. Patria, you
Okay.
have 2 minutes left.
Okay. Yes, this government regulation setting the role of the outer small island in preventing an adverse impact of climate change. And this slide is following the scope of that regulated disaster management, starting from type of disaster to its financing. And therefore, in handling disaster in Indonesia, synergy and coordination are needed from various parties. For example, the government, the community, volunteers, and non-government organizations, and even with the international community. So this is the four main policy and program nationally in disaster management in the coastal area and small island. This is the combination of all strength attribute of resources available within an organization, community, or society to manage and reduce disaster risk and strengthen the resilience. Capacity development is the process by which people, organization, and society systematically stimulate and develop the capacity over time to achieve social and economic goal. In the next, we can see the example for effort for risk reduction. This is about the adaptation and capacity, and this is an example of coastal area recovery, which one of the action plan in Indonesia, so physical and non-physical activities. And this is a recovery of coastal function, so coastal rehabilitation. And this is an example for using artisanal protection and natural protection. And the following is an example of the use of coastal belt and hybrid structure in Indonesia. And this is the last example illustrate how rehabilitation of coastal land by planting mangrove, including making artificial reef and transplantation of coral in a coastal ecosystem. And for the last talk, we have had a very tough year. In fact, we carried on moving forward. This is reflected in the fact that currently almost all countries, including Indonesia, are focusing on two things. First, certainly to stop the spread of the virus 19 coronavirus, and secondly, putting together an economic recovery program and identifying multidimensional challenge, including the threat of climate change and deteriorating environmental quality and carrying capacity. The government of Indonesia is aware of the threat and ensure integration of climate and environmentally friendly activities in existing stimulus policies. Thank you very much.
Thank you very much, Dr. Patria, for your excellent presentation. There is a note from your presentation that the level of environmental hazard and exposure in Indonesia is quite high, which is caused by natural and not natural or human intervention. As archipelago country, Indonesia is not only vulnerable to disasters such as earthquake and tsunami and others, but also vulnerable to hydro-oceanographic disaster, which have a direct impact on coastal areas and small islands areas. To deal with, we still lack of copying capacity. However, coordinating Ministry in Maritime and Infestation had released the policy and programs aimed to improve or increase capacity of mitigation and adaptation, improving the quality of the environment and increasing disaster and climate resilience, promoting low carbon development and capacity development. And this is in linear or in accordance with the instruction or arahan of Indonesian President Joko Widodo. Thank you so much once again, Dr. Patria, for a great presentation. Next, we will have the final invited speaker, Dr. Rahmawati Hussein. Dr. Rahmawati Hussein is Vice Chair of Muhammadiyah Disaster Management Center, one of the largest NGOs in Indonesia. She is also an advisory board member of the Indonesian National Disaster Management Agency. Currently, she serves Supervisory Board of Humanitarian Forum Indonesia. She has been working in disaster or humanitarian related works for more than 15 years. Since 2018, she was selected as an advisory group member of United Nations Central Emergency Response Fund. Dr. Rahmawati will presenting the localizing disaster risk reduction case study of community-based disaster preparedness in Bima and Palangkaraya, Indonesia. Dr. Rahmawati, time is yours.
Thank you, Ibu Dani. Good afternoon, everyone, and good afternoon, distinguished all the speakers and also all the participants. Thank you for the opportunity that given to me. I would like to straight to the presentation since time is only 15 minutes. I'll try to share the screen. Okay. So since this morning, we already talked on the perspective of the academia and also from the government. I'll try to bring down at the community level because the community at the end is the one who are affected most by the climate change. So we have project, the Muhammadiyah, on community-based disaster preparedness in two areas that also affected by the climate change in Bima with the flooding and flash flood, and Palangkaraya with the forest fire. And I will use the action research since I'm also from the university, so working both in the university and also at the community level. This is, I'm just go through. So as we already learned since this morning, that the majority natural hazard right now is induced by the meteorological or climatological events. So in Indonesia, 80% are climate-related disaster. So it's like flooding, landslide, and then drought is part of the one that almost every day we heard in the news. And since 2020, the Indonesian National Disaster Management Agency has introducing a policy on disaster resilient village or the community resilience program. That's called Destana, or also Kelurahan Tangguh Bencana, which policy aim at localizing preparedness as the community, especially Indonesia, where archipelago country, is very important to prepare the community at the either coastal or in any other hazard risk area to prepare for the hazard. And Destana has been a program priority, or the community resilience program has been a priority since 2015, and it has been continued through the 2020 to 2024 of the National Medium Disaster Plan. So in every 5 years, we have the medium plan, and it has been prioritized for implying this. And since up to 2020, although the target is 5,000, we still achieve 1,100 Destana at the community level, and other has been initiated by the university and NGO like Muhammadiyah. So I just want to give a short view if you may not know of the Muhammadiyah, if you are not familiar with. So Muhammadiyah is considered one of the largest with 35 million members, and we have throughout Indonesia. And in 2015, we worked with the Australian government to have a program on hospital preparedness and community readiness, community resilience in the area, since it's very important to include not only hospital ready, but it's also community. And we pick the 2 areas. The project is actually in 9 different provinces, but I will choose 2 cases in Indonesia. Although not only 2 cases like I mentioned, since 2015, we also working with many universities of Muhammadiyah with 170 throughout Indonesia to use the community service by having community resilience project. So I will go through quickly, as we know that the many risks like disaster risk is increased exponentially, and community base has been very important, and localization has been raised in many issues like SDGs. Sunday framework for DRR is focusing on how localizing preparedness and disaster management. So it's very important that disaster, a local community will be strong enough and reduce any risk. And the community-based disaster preparedness has been has been part of the DRM, or community-based disaster management, and DRR. And it's very important that community seen as a key actors. In many studies has been proven that a locally appropriate and locally on strategy for disaster preparedness is crucial, in reducing any risk. And to do that is also important to have collective knowledge and capacities, and also sustainable coping mechanism. And what I presented, I used the action research and I involved in the project. And we do have the FGD, we have annual report, field report, and also baseline and online survey for this project. So we picked 5 urban communities in the city of Palangkaraya, which many are affected by the big forest fire in 2015, and also in Bima that experienced flooding and flash flood. So we carry out the approach or the community resilient program at the village level. And what we do, the important thing is we identifying the key person in the community by recruiting the key actor at the community level. And then we do have TOT and task force. And then we have the program implementation activities by having risk identification and mapping, vulnerability and capacity assessment. And then we do also have the policy and capacity by having train and drills, skill drill, from TTX and to full scale exercise. Tabletop exercise is TTX. And then we also advocating the policy to village plan, and it's all legalized at the village level. So this is the process that we did at the community level, how the volunteer could be the community actor in providing the knowledge on the threat and then the dissemination and awareness. And the most important is the ability to identify risk and risk mapping, where the area and then what kind of risk that the community assess, and then we also help them to facilitate in plan drafting for disaster management, community plan, action plan, contingency plan, and then SOP and mechanism for response. This is part of the process, how to strengthen the community to be able to be to prepare and ready in any type of hazard. And then we also in deciding what kind of early warning system that they agree upon, on flooding and as well as, so they have a different method in doing so. And we also have the stakeholder meeting for community level. So it's very important to agree on the structure, the map, the mechanism, and then the program itself at the community level, how to address the threat. And the third one that I mentioned is about the policy and capacity is very important. They are trained for having different exercise and skill drill, and then how that at the local level included the plan into the development plan. So the hazard plan or the disaster management plan is part of the village plan. It's very important to do that in maintaining the sustainability and in ensuring the project could be funded at the village level through the village fund. So that's part of the process. And we use the indicator that already set up by the community resilient program by the Indonesian FEMA, or National Disaster Management Agency. At the 5 districts, we see that they already reached up to the various component on legislation, planning, institutional, funding, capacity building, and also implementation of disaster management. We see that this component has been applied as part of the community resilience program. And the result that we found that there is an increasing resiliency in the 5 areas that we intervene. So the category, most of them are increasing from 0 to the high resiliency by having the score like the policy. Some still in Indonesian language. I'm not translating it based on the indicator already set up in the by BNPB for the Destana, and then Palangkaraya is also reaching a high resiliency, but in Bima, although it's lesser than Palangkaraya, but it's still considered medium and high, which it is interesting since in Bima has already introduced by the government project. So we see that there is not very high increase if they already introduced the program. So for the area or the village who hasn't introduced the program, there is an increase in policy and disaster plan and DRR forum, and also building up emergency response team and multi-stakeholder collaboration. This is very important to see the component that changed because of the program, and we see the changes. One is the knowledge. Many they are not understanding the threat, so the risk. So it's very important to know the disaster knowledge. From not knowing to understanding the risk is the basic and important thing to increase the awareness among the community. And then there is a change in scale on preparedness and emergency response by setting up the emergency response team at the village level, and then agree upon the emergency or the early warning system, how they will do and use it, and then the risk behavior from less care on the risk and impact on disaster to be more thoughtful. So there is a change in that, and also networking among the stakeholder become more extensive by having the drill and having the engagement at the community level. So it's very important that this need to be based on the community need on having having knowledge and understanding, and then building up the systematic in disaster management. So there is a chance that community become more mitigative instead of reactive. So it's very promising to see how the approach help the community to better prepare. And last one, since already 15 minutes, the most important in the state is the involvement of the management task force member, DRR forum or disaster reduction forum at the village level, and also the village administrative and district stakeholder in the early stage of the project. So the key actors that ensure to also make the disaster risk preparedness happen is the involvement at the village level. And then the second one, the integration of disaster plan into the village development plan. This is also that we learn because any project, if the disaster plan is not included or if not incorporated in village development plan, then they are not very strongly implemented. So they only do all the awareness education, but at the end, if there is no political will at the community level or
Sorry, Dr. Amawarti, it's already 15 minutes.
Okay, then I will end this. So this is the one that we see, the collaboration between government and non-government that been mentioned by many speakers is become crucial in promoting community disaster preparedness. and thank you. So it's very important that we use the various approach to increase the resiliency. And offer to you, to moderator. Thank you very much.
Okay, thank you so much, Dr. Rahmawati, for your valuable and interesting talk. It's really interesting listening or hearing your project with the community. And I see from your presentation that Indonesia launched a disaster resilient village and called Destana with the aim of localizing preparedness and risk reduction at the community level. And you as the mentor or maybe chief leader in Muhammadiyah organization involved actively in this program. It's really I think it interests everybody. And among the project area is Central Kalimantan, West Nusa Tenggara or NTB. For forest fire, haze, floods in Kalimantan, Central Kalimantan, while in NTB for floods including coastal area. And you also mentioned disaster on a local level after the project ended. I think this is happen everywhere with many projects, many projects. Therefore, the community-based disaster preparedness or CBDP focus to bring people within the same community to give self-support, empower, effort, and mobilize resources that villagers have to be able to recognize disaster risk, village vulnerability, and capacity. It's very interesting. Thank you very much once again for your great presentations. Ladies and gentlemen, now the time for discussion. We ask all the participants to raise questions by raise hands or write in chat box. And I saw one question in chat box. You can ask also in Bahasa Indonesia and we will translate it. Please mention your name and to whom the question is addressed. Because the question is already in chat box, one question. So I will mention the question that the question is from Dr. Bokiraya to Ibu Nelly. Ibu Nelly, there is a question for you.
Okay, thank you very much.
Yeah, how is
Can
the
I
pattern?
answer it?
Yeah, how is the pattern of La Nina and El Nino in the last 5 years? Is there a significant impact between large and small islands? How are BMKG educational effort to the community regarding mitigation and adaptation for El Nino and La Nina?
Yeah, thank you very much for the question, Ibu Boki Raya. Yeah, right now I can inform you that the pattern of La Nina and El Nino is changing. Usually we experience this event every 5 to 7 years, but right now it's more frequently, as you maybe notice also. And your next question, how the significant impact? I think it depends on how the origin of the location itself. Because as you maybe remember, on the El Nino, strong El Nino in 2017, if I'm not mistaken, the area that have very high impact is the one that have the forest fire because of the climate, the weather is very dry at that time. So I think it depends also on the location. and how BMKG educational efforts. I can inform you that BMKG already has conducted what we call the climate field school to reach our user in this specific user for instance for the farmer and then for also the fishermen, how they can adapt of these extreme events. So how the let's say for the farmers, they need to change the way that they do the farming. So because of the changing pattern of the rainfall, so it's really affect how the farmers will farm on this nowadays. Thank you. Thank you.
Thank you, still there is a time for question. No question?
Yeah.
Thank you.
Udani. Yeah. Thank you, Udani, for your time and we should we know the main stations usually in the island, yeah, the station, yeah. So how to make some early warning system in the small island? Just we know it's a problem with the internet connection, access, and so on. So maybe I don't know. The BMKG maybe have some idea to develop some early warning system, especially in the small island. And then for the Pak Andreas, thank you, Pak Andreas, and also your nice presentation. I just show in your slide, as just you mentioned, in the Ministry coordinating of maritime and investment also try to make a development in the small island with measurement the sea level rise. So maybe I hopefully you maybe have one place focusing in the eastern part of Indonesia, especially in West Papua. Thank you, Pak Andreas. And for the Ibu Ramawati, thank you also for your time and your presentation. So right now we also make the scene with your activity. So right now we try to how to develop the capacity building in the small island. Just so you know, just I mentioned in the first time, so West Papua have a 4,110 small island. Yeah, this our still how to deal for the disaster management, yeah, especially for the small island. So otherwise, we also make a mapping for the risk identification, vulnerable, and also for the hazard. So this most important thing for our to develop that one. Thank you for your sharing, Rama.
Thank you, Pak Henry. Thank you very much, Dr. Henry. Could you please, Dr. Nelly, answer first and then followed by Dr. Patria and Dr. Rahmawati.
Okay, thank you very much for Pak Henry. So we can meet here. For the small island, it's really challenging for us how we can disseminate our information or how we can also take information from our observation there. So we need to work closely with other government institution especially with the Ministry of Communication. As right now, the government are developing right now the more and more BTS in the small island also, and we collaborate with them how we can connect all information that can be disseminated also with the new BTS that they have, not the commercial one, but the one that built by the Ministry of Communication. And we also collaborate with the citizen itself, with the what is the name? HT SC radio. So because it's very powerful in when we cannot depend on the electricity, so we can use the kind of device also. But for we also realize that it's challenging for Indonesia as a archipelagic country to provide communication that can reach the island. And one solution that we need to have like many small satellite communication. We have examined that we need like nine small satellite to be here in our region. Thank you.
Dr. Patria, please answer the question.
Okay.
From Dr. Henry.
Thank you, Pak Henry. It's a good question. Yeah. As a ministry that coordinate various process implementation activities, including infrastructure project to reduce the risk, yes. We also often invite various technical institutions to discuss about various issues regarding disaster risk in coastal area and small island. For example, KKP, Ministry Marine and Fisheries, as a ministry that coordinate, has a program to increase the community capacity in the coastal area and in the small island. Of course, we agree. We will encourage technical ministries such as KKP, PUPR, and other ministerial to focus in Eastern Indonesia, because in the Eastern Indonesia have the potential for disaster is quite high, as I explained in the presentation. So we agree with you, Thank you.
Dr. Rahmawati, could you please answer the question, and thank you for Dr. Patria.
Thank you, Dr. Henry, for the important issue that you raised, that as we understand that remote island or small island are many in Indonesia, and what we do, or what we can do as the university forum are here, we can use the university community service program as required in Indonesia as part of spreading the community resilient program. So by the like the continuation, yeah. So it will maintain the sustainability. So what we do, like we also working with the University Muhammadiyah in all part of Indonesia to build this, yeah, to reach out at the different islands, not only by the organization, because Muhammadiyah is organization, but the University Muhammadiyah is the academic institution. So by collaboration between the MDMC, the unit that responsible for disaster. We work with the university to continuing for training, not only lecturer or faculty member, but also training the student, the university student. We also working with various BBBD at the local level, at the district level, to also have TOT, training of trainer. So it will help to escalate the number of the area that intervene for the community resilient program. I believe that the collaboration is very important, and we can reach out area that we may have difficulties if we do it by ourselves. But if we collaborate, I think we could reach out as many as possible, all the communities in many area. And we are open to share the result and the process. So we could, after the conference, also could build up the collaboration, for example, even for training, for sharing the process, and then how we could discuss the different approach in strengthening the community level. Thank you.
Okay, still one more question from Patimura 97724. Could you please directly ask the questions?
Thank you, ma'am. Thank you for the opportunity given for me. I'm Rion Saib Salman from Patimura Meteorological Station of Ambon. I'm as presenter in this conference, and I just appreciate with Bu Rahmawati. That is very, very nice to be here and hear Bu Rahmawati present about the Muhammadiyah, what they did the last year. And actually in Agency for Meteorology, Climatology and Geophysics, we have impact-based forecast. So we have to switching paradigm from the weather forecast daily to impact-based forecast. So we need collaboration with the many stakeholders. And I have a question, Bu Rahmawati, about that. Maybe I from in Maluku region, it's same with Papua. Papua have a large land, and in Maluku province have a small island with situation that this is very unique, very special, because the pattern of rainfall is very different. We have many vulnerability in small island and high risk in there. So if we can collaborate, Ms. Rahmawati, do you have maybe staff or local organized in Maluku province, and how we can contact you? So I will contact the BPBD in Maluku province, and we can work together maybe, because that is very important thing. BMKG as the agency has the responsibility to inform the weather services. We have to know what the community want, what the community want about our information, because we have that, and we must to deal with that and with the community. Thank you, Mr. Rahmawati.
Thank you. Should I respond directly?
Yes, could you please, Dr. Rahmawati?
Thank you for the question. As I mentioned, we are open. So we even at the national level, Muhammadiyah have collaboration with the BMKG, with NBB. Yeah. So at the district level, we do have MDMC in 34 provinces. So what we can do, we could contact the MDMC at the district or the provincial level, and then we could have the training together, and then we could also invite BBBD So how we could pick the area that the most vulnerable area, and then we could work on identifying risks, and we could use the support of the university. We have a project actually in North Maluku, not in Maluku, but yeah, we will see if we could extend to Maluku. Yeah, so
please come.
Yeah. Okay, we will see, because we do have the
we
project
will helping you. Thank you.
and North Maluku, because North Maluku is also have 1,200 or 1,200 islands. Yeah, so we also concern on the remote area, but we haven't had a project in Maluku, but hopefully Ambon will be one of our target area in the near future.
Yeah. Thank you, Mr. Rahmat.
Thank you so much, Dr. Rahmawati, and also Bapak from Patimura University. And I believe that there's so many questions we'll be asking. However, because the time is up, so I have to end the session of discussion. Finally, our appreciation to all speakers, because the three speakers, Ibu Nelly, Pak Andreas, and also Ibu Rahmawati presented the great valuable information and lesson. So we would like to present the certificate by inviting the speaker first, Ibu Nelly Riyama. Could you please receive the certificate? And then followed by Dr. Andreas Patria and Dr. Rahmawati Hussein. Thank you so much. Finally, we are very honored to have all the speakers in this conference, and thank you so much for all the invited speakers, which give us the valuable lessons. And also we thank you to all participants. We learn lots from the talk, and this improve our insight from what we listened today. Well, thank you so much, and I give back the time to Mrs. Rina as the MC. Let's give applause, big applause to all speakers.
Thank you very much, Ibu Dani, as the moderator for the discussions, and thank you very much, Ibu Nelly, Pak Andreas, and also Ibu Rahmawati for very interesting discussion. Ladies and gentlemen, now it's 1:09 p.m. in Jakarta time, or 3:09 p.m. in Papua time. I do apologize. We may have no time to break. So now we are going directly to the parallel session. But before we are entering the parallel room, I would like to briefly inform you the rules for parallel session as follows. As you can see in this slide, those are rules of parallel session. First, each presenter must be in the virtual room throughout the session. And second, please rename your account. Fill the first word with the room of the parallel session and the last words with the presenter full name. For example, A_, Muhammad Yamin. To change your name after entering a Zoom meeting, click on the participants button at the top of the Zoom window. Then click more and rename. Third, one presentation is allocated in 10 minutes, with 7 minutes for the presentation and 3 minutes for the question and answer session. Presenters have to close the presentation strictly within 7 minutes. Fourth, session chairs need to strictly control the start and closing time of each session. During your presentation, the session chair will give you notification via Zoom chat 2 times, which is indicating that your time allocation is coming to end. First notification means 2 minutes presentation time remaining, and second notification means time is over, which is finish your sentence and stop your presentation. And the last one, the question and answer session. Participants give question through chat that will be read by chair or directly unmute your microphone, but please ask the chair's permission first. For those who will be joining and presenting in the parallel session, please be note that our parallel session will be divided into 3 breakout rooms. So we have room A, room B, and room C. Yeah, for room A, the discussion will be moderated by Dr. Aplena Elencia Nebles. And for room B, the discussion will be moderated by Mrs. Restia Cristianti, SAMSE, and for room C, the discussion will be moderated by Dr. Johanna Noradika Maharani. Okay, Mas Ivan, could you please to share the presenters' name and their topics in the screen? Okay, thank you. As you can see in the slide, there are presenters' names and their topics. So you may also check your name in every room, and after this, please proceed the room. So in room A, we have like 15 panelists, and in the room B, we have we have around 17 presenters, and for room C, again, you can take your name in every room, and after this, you can enter the parallel room. And for room C, we have 16 presenters. For all moderators in parallel sessions, time is yours, and for all presenters, have a great presentations.
Thank you, Ms. Rina, for the time.
Thank you, Ibu Resti. Excuse me. Ibu Resti. Moderator room B. Oh, belum. Masih proses.
Excuse me.
Saya kedua itu bukan karena COVID asalnya, tapi ada konsumen produk untuk menambah kan deteksi kayak sanksi negatif, bekerja negatif. Dokter sekarang ini sudah sembuh, bekerja di banyak apa? Kita mau belajar malah waktu itu dari langsung tidak ada bisa
Halo.
Pak.
Halo, terlempar lagi saya.
Terlempar lagi.
Atau di sini aja deh kita.
I'm sorry. I can continue with my presentation.
Oh, I get lost my room.
Saya terlempar lagi.
Lempar.
Teknisi.
Kita di main room aja dah.
Wow.
Lempar lagi.
Excuse me.
Oh,
okay.
Bencana teknologi ini. Terus kemana nih?